Well, believe it or not, we're here. Hey, folks, this is Mark D'Antonio with SkyTour LiveStream, and we are joined with the famous astronomer Daryl Mason. Hello, Daryl. I'm not worthy. How are you?
Hi, Mark. I'm not worthy either.
Okay, we're both neither worthy nor. Well, Daryl's probably happy tonight. I actually had such a incredibly tough night out in the dome getting it set up for some reason, and then all the software in here failed. The software in the dome failed. The hardware in the dome failed. I think I actually punched a hole in the dome tonight.
Oh.
Yeah, I did. It's thin plastic. I think I punched a hole.
Wow.
Yeah, I got really mad. Frankly, right now, we're okay. I mean, you notice, the one thing you do notice is that down here, the ops screen is missing. That's because the operations camera simply has not chosen not to work tonight. That's just one little thing, of course, just added to the list. But no worries. Right now, we have a massive star in the view right here. This is Antares. Antares is beautiful, and it's just a amazing red giant. Actually, it's a super giant star. And I'll bet you Daryl knows how big it is if you put it where the solar system is.
Actually, no. Not. What are you saying? How far away is it?
No. I mean, in terms of, like, if you put it where the sun is, how big would it be in our solar system?
Oh, golly, really? I don't know offhand. I'd say it's comparable to Betelgeuse. Maybe.
Yeah, it is. It goes out to about Mars or so.
Yeah.
Yeah.
It's a double star too, believe it or not.
Yeah. And right next to it, as you mentioned before we went live, there of course is a beautiful globular cluster that we're going to look at tonight. And guys, I got to tell you, I looked outside and I saw that the sky was stunning. I'm going to just see if let's see if our camera works here. Let's see if the all sky camera can work. Look, not found. Wow. Welcome to tonight. Tonight is a night of absolute bullcrap. It's like, and now the all sky camera can't be found. And then it's right there. I know it's there. Whew, I tell you, I swear, I almost want to strike the dome with lightning just to see what happens, because that's just maddening.
Don't do that.
Since we don't have commercial breaks, I can't go out and, unless I move the dome, I can't go out and try and see what's wrong with that camera. But anyway, I do want to welcome those of you that have been here and been waiting for the stream. I so apologize and wholeheartedly for delaying the start. But to those of you that are here, I want to welcome Bob Harless, and Terry Groff is here. Okay, and Rascally Rabbit DK is here. Tara, hello, is here. Marianne is here. And we have a whole bunch of... and what do you mean, Marianne saying, okay, we're all going to bed? Get out of here. Don't you be going to bed. You can't go to bed. Hello, Daisy and Zoe. Nice to see you guys here as well. Thank you for putting up with my lack of a on-time start. Mr. Dingo 57 is here. I have a dog named Dingo, by the way. I looked behind me to see if she was here, because usually she just hangs out right behind me, but I think she heard me getting angry and ran away. Hello, Gina. She probably did. Gina Leone is here. Hello, Gina. My business partner's last name is Leone, by the way, just so you know. We used to call him Lee One because he was a third-degree judo dojo owner and a third-degree black belt in judo. I was only Taekwondo, so see that people argue back and forth about whether Taekwondo was better than judo and so forth, and you know what? It doesn't matter. So hi there, W is here, and I see Nick is joined us tonight. Hello, Nick, and you guys are lucky tonight. Hello, Rachel. Nice to see you, because we are actually going to be taking some photos, I hope, of some very nice objects in the summer Milky Way. All right, and I did confirm with Marianne actually today that we are definitely, and I mean definitely, going to be in Arizona on the 25th of September to do the building construction. It's all about COVID. It's the only reason we haven't gone yet. Postponed 4 times. All 4 times I was angry and kicking things because this is not fair. I want you guys to be able to see this stuff. Yes, and I do want to make sure that I live. Okay, but I think it's really important that I just make sure that it's done right, you know. So I err on the side of caution, you know.
You
So
say you're going late September now?
yeah, September 26th actually is when I'm going.
Oh, well, maybe it'll start cooling off by then.
See, I don't care. I like the heat. You know, I like the Arizona heat. You know, I've been there every month of the year, and I've been there when it's what they call cold. And I'm like, what? 55 degrees is cold? Wow.
Them it is.
Yeah, it is actually. And I'm sure that staying there in the heat for 2 seasons or so, and you'll probably also think it's cold. Okay, so
I'll tell you, summer's on the wane here.
yeah.
I mean, it's still hot, but I'm seeing signs already that, you know, summer goes fast here.
Yeah, that's true. Same here. It's almost gone. Just for those of you that are joining us who may have not been here before, the upper left corner here, this here that you see, this is the camera, the telescope control cluster. This actually controls the scope. This controls the computer of the scope. Sometimes I'll go in here and make some adjustments. This is the focus of the telescope. And down here is our filter wheel. Currently we're on filter 5, which is no filter. It's a hole. All right. If we go to filter 1 by clicking this arrow, you'll see this. The star blinks for a minute, and then it gets a little bit dim because now we're looking at it through a narrowband filter, and that's why the other stars seem to go away. All right. And then if we go to 2, it's a slightly wider narrowband filter. You can see the stars peek back in a little bit. And then 3 is a spectral band filter, which is really interesting with Antares. We have a spectrometer that we're going to be adding to the observatories, and I have it here on my right, and I haven't installed it yet. This is just a prismatic view using gratings. And if you look, you can actually see here, you can see that there's some horizontal lines here. These are actually horizontal lines in the spectrum of this star, and if we identify those lines, we can tell what's in the star's atmosphere, and that's how we do it in astronomy. You can see some of the lines here. You don't use this primary blaring spectrum because they're all too large there. You got to use some of these other secondary spectrums out here. All right. So anyway, so that's pretty cool. That's 3, and then 4 is actually just a dark disk, so we can take dark frames when we're taking long time, lots of exposures. We take dark frames so we can subtract out noise. And then 5 is what we started with. Okay, this is looking straight through without any kind of filter at all. Tonight we're going to start with filter number 2. So I'm going to go back to 1 first, and then go over to. Okay, that's 4. Sorry, I went the wrong way. And now we'll go to 2. So we're going to look at the somewhat wider narrowband filter. And I just have one little adjustment here to make. And that's that I'm going to make sure I know where to put things that I want to focus. So that when we do focusing, for instance, I can actually take us, let me just go here and just do this. I'm in a focus mode right now. So I'm going to go and move us over just a little bit. Okay, and you'll see Antares come into the focus view here. Okay, it's a very big view, okay, and that's very important because using this view, we're going to actually be able to now focus. So if I go ahead and start using the focus buttons over here that you see, you'll see the star changes and you'll see a donut appear. That donut hole you're seeing opening up in the center is an artifact of the telescope itself. It has a secondary mirror up near the front. We call that a secondary obstruction. But there, around it is all this extra clear glass, and that's what you see around here in the white area, in this orange area. The round little thing there is just the blocker that's sitting in the front of the tube, and it's surrounded by this glass through which all the light goes. And so we don't miss anything. Okay, and now we're going to go back down and bring it down to as sharp a focus as we can get. And we're going to go back just a little. Antares is actually kind of low in the sky. Okay, so but let's just try. Let's move it out of here. Let's get out of the focus segment here, and let's bring us over toward the east. We'll move the telescope to the east. All right. Okay, there we are. And we have an auto guiding system on the telescope, so it actually guides quite well. And I tested it to 30 seconds earlier. I'm not going to do that right now. I'm just going to do 15 seconds at 5,000. Now, on the left side, you saw the telescope control. On the right side, okay, this, of course, is the window into the observatory. You can see the camera there, the low-light camera that's looking at the telescope. And in fact, you can actually see that secondary obstruction I was talking about, which is right here. You can see that right there. And if you're looking in there, that's the secondary obstruction. And this is that open area around it that I talked to you about. And this is what makes it look like a donut. This is the automatic cover that goes up when the telescope is parked in place. And it's not right now because, of course, it's looking at something in particular. So let's go back and look at the camera settings here, and I shall now get rid of the camera for a moment. Now here you see this is the shutter settings over here on this side over here. All right, we have the camera speed, or our setting rather, the time right here, 15 seconds it's set for, and this is the sensitivity of the sensors. It's set to 5,000 ISO. This camera can go to 409,000 ISO. And you might be tempted to say, oh, take a picture like that. And it just shows you a lot of noisiness because of the fact that the sensor is really, it gets noisier the higher you go. So the maximum usable really is around 51,200. Going beyond that, and it's really hard to get rid of the noise in the final images. Let me show you what I mean. Here's 5,000 for 15 seconds. Let's just take that picture. Now we also have an issue sometimes where the dome will get in the way because we actually are using an actual dome. In Arizona, for observatory number 2, we don't have a dome. We actually have a building where the roof just comes off and it rolls off. You see, now the dome's in the way. So we actually already have an issue with the dome here. That's what this red is. All right, you're looking at the red of the light inside the dome that I have there. All right, so that means if we want to continue looking at this location, we will have to move the dome. But what I would like to do instead, perhaps, is to just continue to view from a point of view of near Antares and to its east, which is the summer Milky Way location. So Daryl, I think we'll have to skip M4 tonight.
Okay.
For now, we might come back to it, but let's just go see. So let's go here and go back to this. I could tell there was something blocking it because it was starting to fidget a lot in the screen. Now we actually when we actually look at the sky, we control with this particular program called Stellarium, and you'll see a crosshair where the telescope is currently located. And Stellarium shows us that Antares is kind of low right now. It's literally only about 12 degrees above the horizon. So we got a late start tonight because of my issues out in the dome. But we do have a lot of things that are pretty much, just past south. So we're ready to look. This is my actual horizon, by the way. This is the real view that I took of my area here. Let's start tonight with the butterfly cluster. All right. So I'm going to tell the telescope to go there, and you'll notice immediately that Antares is going to rush right out of the view. All right. And then we're going to go to a bright star in its place. So there goes Antares. And the telescope is heading toward a bright star that's near the butterfly cluster, and it's using that as a guide in order to get to the butterfly cluster. And where are we? We're over here, right there. And then once we know and get that star centered up, then the telescope is going to race right over to the butterfly cluster, like that. And then we should be heading over to this cluster right here, and there it is. Yep, and we do have a view. I mean, this little shape gives us the angle and the approximate size of the field that we're looking at. Okay, so we're close, not bad. All right, so there's the butterfly cluster, and what we're going to do is we're going to I'm going to go into the computer and tell it to give me just a little bit more motion. That's better. Okay, and now we're going to head east a little bit, center her up like this, and this is the butterfly cluster. Now what we want to do is focus these again, only because Antares is too bright to really do it well. So we're going to do this, and now we'll have enough stars in here, as you can see, to actually focus. So now we're going to do this again. So I'm going to test it right now. Okay, it's out of focus. You saw some of the stars disappear because they were already at the limit. And now we come back, and they will just pop into view. And because it's somewhat lower to the horizon, it's twinkling a lot. That is just, unfortunately, what happens with this system like this. All right, and I can get rid of this. There we are. Okay, so now we should have a nice view. When I take a 15-second at 5,000 photo of this, we should have our guide star by now. We're using, as you can see down here, position 2 of the filter wheel that we're in. That's the slightly wider narrowband filter. And we're going to now do a 15-second shot of that. So for the next 15 seconds, we're just going to be waiting for the exposure to come in. But no matter, because we can just go over and look at the last images that we took. It doesn't look too good yet because we have Antares. We did have a white light shot, and it was out of focus because I didn't focus it. But look at that. This is a beautiful shot of the butterfly cluster. Check it out, Daryl.
I am. Oh, that's really nice.
I
noticed the red star on the left last time. I don't remember the dimmer red star there on the right side.
Yeah, and see, when we look at these clusters, hey there, Gas Mask and Dee Dee, how are you? James Dugan. When we look at these clusters like this, one of the things that we'll see is that when they're star clusters like this, typically the stars are approximately the same age. But when we see a red star like this, that shows us something different. It shows us that the star is either more evolved than some of the other stars in the cluster, or it's a much lower mass for some reason whatsoever. And that there's a dozen reasons why that could be the case. But most likely what we're viewing is this beautiful young cluster of almost the same stars of the same age, okay? But these stars here, these red ones, so this one, we got one here, we got one there, got one here, we got one there, and one there, and there, and there, a little fainter. Those are probably superimposed on the cluster. They're either closer or farther away. So it's very, very possible that that's what we're looking at. All right. In fact, in most cases, that is what we're looking at. Now, we can also do a zoom image too if we want. And, you can see what I was talking about with the noise. When I talk about noise, this is what the noise looks like. This is 5,000 ISO. At 409,000, it's much more problematic and shows up even brighter, So it's really not that good. So we don't like that. But I really like this cluster. That's the butterfly cluster. And Daryl asked last time, I think it was you, that said, do you see the butterfly?
Oh, yeah.
Okay.
And yes, I do. I still do.
Okay, so these are the wings. One here and then one here, yes?
Yep.
And this is the body.
Yeah, if you imagine the wings as two lobes like a butterfly's, it's got the bigger upper lobe and the smaller lower lobe. The body's kind of running down the middle, a little bit upper right to lower left. Then the top half, the upper wing To the right is the upper lobe, and to the left is the lower lobe. And then down below the body, you've got the rather larger upper lobe and lower lobes of the right wing.
Okay.
That's how I see it, anyway.
Okay, I'm sure you're one of the few. Because to me, I'm not that good at seeing those kinds of things, but I do see the beautiful stars. Oh, hey, I see Keith's here. Hey, Keith, how are you? Welcome. It's good to see you. And Gas Mask, I said hi to. Yeah. You guys, you make the world go round. Keith, you're responsible for me doing any of this in the first place, so you just have to stick around now. You're the only reason I'm streaming. That and Bill Skywatcher. So anyway, yeah, that's beautiful. So let's go out now and let's go back to our view of the cluster. This is the cluster as seen just through the telescope, native right now. I want to take us though. Let's go and look at our beautiful view here of the sky. Let's go look at something else. Yeah, I know you're thinking too, Daryl. I don't even have to say it. You know, we're going up there. Don't worry.
I'm innocent.
Yes. Okay. The higher up we go in the sky, the better things look. And so tonight, I think we'll have a fun time. Let's go check out the Lagoon Nebula for now. Right now, you watch the stars here. Will possibly just zip out of the screen here momentarily. There they go. They're gone. And we're heading now up to here. And in order to do that, we have to first go to a star down here. And it's using Al Nasl again, which is it's in the in Sagittarius Teapot. And after it aligns Al Nasl, it's going to then head up to this. That's called high precision pointing. So you can see it centers it up. And it doesn't have to stay there for long. Once it sees it and centers it up and aligns it in its internal guiding reticle, it's going to take off. All right, so here it goes. And 1, 2, 3. Ah, come on. Don't prove me wrong. There we go. I was just a little too fast. All right. Here we go. And now we're seeing this beautiful nebula down here. And we shall bring that in. Hey, Keith, you're saying, oh, that was so 2 years ago. Ambient noise? Okay. Keith's using ambient noise to relax. I guess that's better than using somebody screaming in your ear, like, all night long or something. That would be bad. But it'd be kind of fun. I'll do it.
Best ambient noise I ever had. 1980. I was up in the high country, and I was living in a little log cabin without electricity, and my running water was a cascade coming down the bottom of a hill. It was like a little waterfall higher up, and I was at the bottom of the hill, so it was more of a cascade, jumping down the rocks where I was. But that little stream sang me to sleep every night.
Wow.
And I just loved that.
That's really cool. I mean, I spent, when I was in Norway last August, actually, a year ago, yesterday or the day before was when I went to Norway to do a speaking tour. And there was a place where there was waterfalls everywhere, first of all, in Norway. And you couldn't go anywhere without hearing the rush of water somewhere.
Uh-huh.
And it would come from the glaciers way, way up high, and you could see the glaciers. You're in a t-shirt and shorts, for instance, down the bottom. But up high, it was below freezing, and where it was at the line of the freezing, up there, the glaciers would melt, and that runoff water would just come down like a torrent, and it was just beautiful. Absolutely beautiful.
Yep. Lots of good ions floating around waterfalls, too.
What's that? Lots of good what?
Ions?
Oh,
Negative ions?
Yep. That's right. Yep. Keith, what do you have you ever done like a sleep or a deprivation tank where it actually takes all the senses away because you're floating? Have you done that before, Keith? He says he's doing this ambient noise. Wow. This is the Lagoon Nebula.
Nice.
Yeah, it's looking pretty tonight. Look at that. We're just a little bit off, but I gotta tell you, we're actually seeing there's some more detail in there. That's actually pretty nice. Wow. So, and that was, we might be able to focus that just a little better too, because it looks like it might be just a little bit soft focus. But let's go in and do that. Let's focus. So we go in and we grab up our focus box here, which is just what we need to do this. We come over here and I will now bring us westward. Go west, young man. And when we see stars coming in, we're going to move them into the middle of our focusing box here. I'm in the middle of actually writing a program to actually do automatic focusing. So it's going to do this all automatically. And I won't even have to tell it. When it sees something in the view, it's going to immediately start to focus it. And I won't have to do that. You know, I had to change that song because it might get a copyright violation. Okay, here we go. Let's see what we can do. Okay, we're coming out of focus here a little bit. Now down into focus. And let's go back a little bit. Okay, I'm going to come back out and we can run it eastward a little. Alright. That's where I want to be. Now we're going to come back. That looks good. Let's try that. Alrighty. And let's go to the east a bit. Now, the rule of thumb is that when the telescope gets into a position, usually you have to wait about 11 seconds. That's the time it takes for the telescope to actually go in and find the guide star again. And that's what I'm doing. So at 6400 for 30 seconds, let's give that a shot. Actually, we already did that. Let's do 8000 for 30 seconds with this newly focused shot. See what we get. Well, Keith, how did you do that? How did you actually do it? I don't know if you explained it in chat, but I didn't see it if you did. Dude, thanks for coming out. Sorry we got a late start. All right. Look at that. Now, you may think this is really looks pretty, right? And it does. But I'm going to show you a difference now. What we're going to do next is we're going to take the filter and we're going to change it to the narrowband filter, and I want you to watch the difference in here. Okay, so we're going to go back to here and we're going to bring up our telescope control panel system, and we're going to change this filter wheel down here to 1, and you'll see the stars blink a bit, and now you'll see that they're a little dimmer. Now we're letting through only the wavelengths, only that light that is going to add to the detail in the nebula, and we're excluding much of the other light. So let's go do this again. I will check the focus, but I do believe that with this particular, I think we're okay. Between 1 and 2, those two filters will actually show us the same relative thing. Okay, so here's this. Now, here we go. 30 seconds at 8,000 now again. And
Mark, on the screen you're sharing with me, could you move that right-hand box a little farther to the right? It's sort of blocking chat a little bit.
Oh, it is, isn't it? I'm just going to do better than that. I'm actually going to shrink that box a little bit.
Very good. Thank you.
No problem. Thank you, Daryl. All right, so here's the regular filter, okay? And now this is the specific filter with a narrow band. Look at the difference. Okay, there's that versus, well, we'll say that, okay, versus this. Okay. I think that's a big difference there. Now we actually refocused too, so it's actually, you can see the very, very sharp detail in here. Very, very nice. Very, very nice. Wow. Okay, so between that and this, the sky's a lot darker. You got a lot of more detail. So the narrowband filter, you see, has a place, and we use those in astronomy to combat glows that are in the sky that we want to get rid of, such as the glow from lights. And we hate all that, you know. We just don't like it. What a beautiful night. Okay, I'm going to go right to a minute on this and stay at 8,000. All right, so we're going to go to a minute and see how that works, because 30 seconds work just fine. Yeah. Now, here is what's called the raw file. All right, this is the raw image. This is the JPEG that I'll hit now. So here's the raw and here's the JPEG. See the difference? JPEG, raw. JPEG, raw. This file is unaltered by the camera system. But this file has been altered. It's been altered because it's sort of been softened a little bit because the algorithm that JPEGs use to save their data will tend to make black things that are near the same blackness all the same blackness, and it makes the file smaller by excluding a lot of that extra data that it will have to use. The raw file, on the other hand, doesn't do that, and we only use raw files. Now look at this image. This is the Lagoon Nebula at 1 minute. Check it out. Is that not beautiful? Wow. So this is 1 minute. This is 30 seconds. See the difference? A lot more light, huh? And it's really looking pretty good. The guiding is really good tonight. So what I'm going to do is I'm going to dare to do something else, Daryl. I'm going to go and try to actually do this for a minute and a half. I have a bunch of other things we want to look at too, like the Trifid Nebula and so forth, right? Who doesn't want to see that?
Sure.
All right, so we'll come back here. The Lagoon Nebula is a phenomenal nebula. It's a crazy beautiful nebula. This is right there, right now, on your southern sky. I should say on the southern horizon if you're up north where I am. And you really can kind of sort of see a little bit of it with binoculars. You actually see a lot of it with binoculars. Not really too well with your eye. Depends where you're located. If you're in the middle of the desert, believe it or not, you can see this with your eye. Not like this. You can just see a fuzzy patch. Orion is even brighter. Orion Nebula. But this,
yep.
Yeah, this nebula here, there's a couple of really cool things. First of all, we've talked about this. This highly red area here, this is the heart of this nebula. It's being powered by a star right there. It's an O-type star, which is the hottest and bluest of all the types of stars. Let me just go to this guy. Okay, there. And it's really hot and blue, and it's causing this amazing ionization of all these hydrogen atoms out here, out to a certain distance. Out here, no. Out here, it's responsible for glowing because these other stars are interacting with the hydrogen gas, and they are sharing their ultraviolet radiation as well. Hot O stars like this, wow, that's 1.5 minutes. Look at that. Wow, not bad at all, Daryl. Look at that.
Yes.
Hot blue stars, they give off their radiation mostly in the ultraviolet range where you can't see it. Yet they're the hottest and bluest, and you can see them as hot and blue. But they are just so immensely bright, so to speak, in the ultraviolet range. And in the ultraviolet radiation spectrum, they are causing the hydrogen atoms in this nebula to ionize. And since hydrogen atoms only have one electron, when the electron gains enough energy, it will leave the atom, leaving only the nucleus behind. And now the electron is floating out in the space, between atoms, and bumping into other things out there, losing some energy. And then it will immediately, because it's negatively charged, and the proton that's in the hydrogen nucleus is positively charged, it's always being attracted by something. It's always being pulled by something. And the electron will be pulled into the atom where there's one spot for one lucky electron. And when it goes down into the atom, it actually gives off light as it releases its final energy to find its stabilized energy level again. And once it does that, that light is a characteristic color, and that color happens to be a pinkish red hue. And that is what we call the light of hydrogen alpha, or H2. H2 is, H Roman numeral 2, II, and that means singly ionized hydrogen, not doubly ionized, because H1 is just the nucleus of the atom with the electron already going around it. That's the base state of hydrogen. So the base state of hydrogen atoms is that they are neutral. They basically don't have any net charge. We've got the +1 in the proton, the -1, so to speak, in the electron, and so there's a neutral gas. But if you ionize it, then that gas has a +1 charge, and the electrons are out there floating around with a negative charge. And then when they rejoin, it goes back to being neutral. But in the process, it's going to give off some energy as the electron dives back into the atom and stabilizes on an energy level. It gives off a little bit of energy, which causes this beautiful red glow we see in all these nebula out there. And we call this a stellar nursery because that's exactly what this is. It is truly a stellar nursery. It is a birthplace of stars. You can see many of them right here in this view. All right. You can see this O star right here that's powering this whole part of the nebula. And you know what's interesting? That O star is only a few 100 million years old, if that. Maybe it's only 15 million years old, 10 to 15. And it's not going to last a lot longer. And its destiny is always supernova. So this location here is a location of a future supernova. And when that happens, there'll be a supernova remnant inside the Lagoon Nebula. Very, very interesting location. Yep. I'm just going to check here, Daryl. Okay, I was just checking to see if Amanda had responded to us. She has not. So she may not be joining us tonight. She's probably sleeping.
Yeah.
She's probably sleeping.
Probably sleeping.
Wow, so this is gorgeous at 1.5 minutes. So I'm gonna do another one.
It's very nice.
Yeah, I'm gonna actually dare to go up to. I'm gonna push the limit. Should we try 2.5 minutes?
You're insane, Rebus. Sure, go for it.
Okay. We're gonna do
Mark, Ronald asked a question a little bit ago. What are the dark lanes?
Okay. If we go back to that image, let's do that right now.
There's Carol Carl. Hello, Carol.
Hello, Carol. Ronald, to answer your question, and hey, Tim F., how are you? And Cheryl, Texas. Hey, how you doing? To answer your question, Ronald, about the dark lanes, if we look in these nebulae, we'll find a lot of these dark lanes like this. You're right. And we know that there are a combination of a solid matter with gas as well. Because if it was gas, we would see through it. Okay? Unless it was glowing like the hydrogen here. Okay, so what we're seeing here is, in typical form, we're actually seeing molecular hydrogen in here and other types of gas that also is mixed with dust. The soot, the dust, the material created in other stars. Large stars, when they go to red giant stage, they will create molecules of material that could eventually accumulate into dust when they coalesce with each other. This is something that has happened for billions upon billions of years in the universe. And when enough of this material coalesces into something that can become a solid object, we get something like we're standing on, a planet. Because if you think about it, a calcium atom is very, very tiny, but 20 billion calcium atoms is a lot more. And then a trillion billion calcium atoms is even more. And as these atoms accumulate in these nebulae that form planets and stars, as these atoms accumulate, then they will form a spherical object, because in the absence of another gravitational force, the shape that the universe is tending toward is a sphere. So all objects that begin to gravitationally coalesce will tend to gravitate down toward a spherical object. Now you might say, well, how come asteroids are irregular in shape? Because asteroids are objects that are, a little bit of a problem there with the guiding, but it still gives me an idea how 2.5 minutes looks. Okay, asteroids are objects that may have been larger at one point, but they are not constrained to be spherical unless they're a certain size. And once an asteroid reaches a certain size, then they tend to round themselves off, actually, because the gravitational forces and the pressures and the tidal forces created within itself are more than enough to force this rearrangement of the crust. So when they're small, they can rearrange into craggy shapes and become craggy shapes. But when they're larger, they must form a sphere.
Mark, I think it was actually the last image. You had zoomed in at one point, and to the upper left of the little hourglass shape there, farther up. Yeah, okay, you can see it right there. There's a skinny little tendril right there.
Okay.
And it has a couple of red stars at the base, and then one a little higher up. Could that be something analogous to one of the pillars of creation? I wonder if those stars are coming out of that tendril, or being born in the tendril.
You're talking about these two things right here?
Yes.
Okay, those two things right there may be stars, but I'm also noticing there's a lot of noise. Okay, there's noise from the filter that's generated, and that may be noise.
They were in the other image you took too before this.
Okay, let's go see. If you're right, then you're right. Okay, they're all good. So these are probably stars. Actually, I see 1, 2, maybe 2 more. 1, 2. So maybe it's 4.
Right.
Yeah. Okay. So yeah, if those are at the distance of that tendril, then it's likely that they were born there, and born within that tendril. And it's possible that these are young stars. But if it didn't have a whole lot of mass, okay, they could have formed M-class stars. And so that's possible as well, because the cluster tends to be young, okay, but it can also have stars in it that are a lot less luminous and possibly also obscured by some of this dust. So right. in a sense, what you say is possibly correct, that this may be the we go back to this one. Probably it's a little not quite as good, but maybe this one. You can see these tendrils sticking up. It's sort of like the pillars of creation, and they may very well be made of similar chemical composition. In fact, we're going to go check out the pillars of creation. I think we should, don't you?
Sure.
So we're talking about it. So what we're going to do is we're going to take our view here, okay, and we are actually in the Lagoon Nebula here, and we'll come back to the Trifid, but let's jump up higher and go to this location. Since you mentioned the Pillars of Creation, Daryl, I think I'd like to take us there. So watch the stars pop away here in just a moment. Here they go, ready and go. And now we're heading to our alignment star, followed by the location that we just set up on here. And you'll see that these north, south, east, and west controls for the telescope are dark, indicating that we are in motion with the telescope. And to see that, let me see if I can show you that. If this will come in. All right. There goes the telescope. You see it moving there subtly. And let's see where it went. All right. And what I'll do really quick is I'm going to come over here. I'm going to go back one filter to the white light filter, which is just white light. And that's not focused, but there is our target, what we're looking for. We are where we need to be. So I shall now go back up to the narrow band and go to the slightly wider narrow band filter number 2. And now we're going to do a 30-second shot at 8,000. All right, and see what we have. This will be the Eagle Nebula Measure 16 that we're looking at. And that will pop in here in the view momentarily. I think you'll like it. Yes, Carol, those amazing pillars. Rascally Rabbit, I think I said hi to you, but hey, hi again. Okay, and here we go. Now, you can see the pillars, and I'm not happy with the guiding. We're going to do that one again, because it's so much better when it's just it's sharp and better. Sharp and clear. So let's go back. Okay. Daryl, I've been trying to look at the chat to see for questions, and I know you caught one for Ronald. Thank you. Have you seen any others?
Not that I recall.
Okay.
I'll try to mention if I do.
No worries. Thank you.
If you didn't see a butterfly in the butterfly cluster, do you see the eagle in the Eagle Nebula?
I do not see the eagle in the Eagle Nebula, but we got better quality shot here. Well, maybe I do, because I see this is the beak, and then this is the mouth, and then it's like a head of the eagle with the eye here, right? I mean, I see a head of the eagle there.
That's not what I see.
Okay.
But hey, as long as you see an eagle.
I know.
No, what I see as the eagle is actually the pillars of creation themselves. The head of the eagle is the upper pillar. His foot is the lower pillar. And behind, to the left of the upper pillar, the bigger dark blob, that's his wing. That's how I see it anyway.
Huh. Okay. Isabella, yes. What is your question? Oh, the Bubble Nebula. Yeah, it's possible to see it. Indeed. I have to look. That's in Cassiopeia?
Cygnus, isn't it?
The bubble?
Maybe I'm thinking of the Crescent Nebula.
Oh, yeah, Crescent's in Cygnus. We should look at it. That's right overhead. Okay, but let's take a look here. Okay. first of all, let's go back. Isabella, I'm going to check that out for you. And if it's up, we're going to check it out. It's beautiful, and the telescope gives us such gorgeous shots of the bubble. I'm going to go to this other filter here. We're going to go to the narrow band filter. And then we're going to take, and we're going to go to settings here. And we're going to go to just, instead of 2 minutes, we're just going to do 1 minute 30. Okay. And we'll do it at 10,000 ISO. And there it is. So this is our camera settings. We're all set. Off we go into the wild eagle yonder. Meanwhile, let's take a look, because we want to look over here. If we're going to look in, if we're going to find it, we're going to find it over here somewhere. I thought it was in, maybe it's in Cephas, the Bubble Nebula. You know what? Why don't I just do a search and find it, right?
Hey.
Bubble Nebula. Okay, yeah, Cassiopeia. I thought it was. And
my bad.
No, that's okay. And it's actually 40 degrees above the horizon. We should be able to see this. I'll have to move the dome, but if you folks don't mind, I can do that. But first, let's get our shots here and see what we get. All right, so now we're going to, we're taking 1.5 minutes, and we're going to see how this looks, the eagle, in 1.5 minutes with the narrow band filter. The shot I took of the eagle and that we processed here and made public, gosh, oh, it takes your breath away. This eagle nebula is so beautiful. Oh, darn it all. That's an error. I think that I can fix that. So let's go back here and let's go to the guider and get down to and let's try this. All right, and now let's do it again. See what we get. And when I go out there, I'm going to also see about the connection of the all-sky camera so we can look at the Milky Way in the all-sky.
Okay. While we wait, folks, you know, I talked earlier about how you can kind of tell summer is on the wane. If you go out and you can see the teapot in Sagittarius this time of year now, you will see that the teapot is tipping over to the right, like the tea is pouring out of the spout. And the Milky Way is the steam coming out of the teapot spout. It's a naked eye thing, you would see.
Yeah, let's show them that.
Yep. See, there's the teapot.
Here's
right
the teapot.
Behind the
top,
right behind the observatory cam.
The handle. And, oh, duh. Yeah, thanks. So there you go. There's the back, and there is the back of the teapot. There is the body of the teapot. The spout is here, and it's pouring out some hot steam that's going up into the sky.
Yep, that's the Milky Way.
Yep. All right, let's see.
And if you can find the tail of the scorpion farther to the right, you don't have to do that, Mark. If you draw a line from the tip of the spout of the teapot to the two stars that make the tail of the scorpion, along that line, about in the middle between, maybe a little bit above, is the very center of our galaxy.
That's right.
Where Sagittarius A star is.
That's right. Sagittarius A is the supermassive black hole, the SMBH, in the middle of our galaxy. Well,
that one looks nice.
Here's a better shot of the Eagle Nebula, guys. This is 1.5 minutes, and you can actually see these pillars of creation right here. These are the pillars that Hubble took that famous image of right here. Gosh, they're beautiful. Really, really nice. I'm thinking that's just beautiful.
It is.
Yep. Nice. Ronald, thank you for that post of the link. Very kind. Yeah, so that's beautiful. I think that when we look at Measure 16 like this, we really do have to look at some of the other things nearby, for sure. You know, I mean, I think it's really, really good to head down and look at the Trifid Nebula. Okay, we're gonna go there now. Check it out. Okay, so we're on our way. You'll see a star come in again. Again, there it comes. That's going to be the star used as a guide. Uh-oh. I saw a sign that said USB device not recognized. What USB device? Better not be the camera. That would be a problem. Keeps coming up.
We're going to the Trifid now? Trifid?
We are.
You wound up catching a good picture of the Eagle there.
Yeah, that was beautiful. Okay, so we should be here now. I noticed a star. We are there. And so we should be at the Trifid Nebula, but I don't see it. But I'm going to actually figure out if it's visible. Gotta go to, yes, it's there. These two stars are the dead giveaway for those of us who are familiar with the Trifid. Okay, so we're going to go back to narrowband. Oh, now I can see them actually. All right, we're going to do 1.5 minutes right here at 10,000, giving it time enough to get its bearings and get a guide star. And so off we go. And there's our eagle. That's a really pretty eagle. And this is the raw. Like I said, the raw image is better because you might think it has all this stuff in it that's really bad, like this noise. But I get rid of all that. I can get rid of all that in the processing. And by getting rid of the noise, you end up with a really, really beautiful looking sharp object, you know, and I just, it's really pretty. Well, I don't have to tell you, you know. And the eagle isn't just here. The eagle goes throughout all here. And when we go to Arizona, we're going to be able to capture all the rest of the eagle, not just the one famous part here. For instance, in Orion, I took pictures of Orion just with my camera. And I caught a famous loop of nebulous detail called Barnard's Loop. Easily visible.
Yep. I'm sorry. Go ahead.
Oh, I was saying it was easily visible.
Yep. Barnard's Loop is not hard to catch in a wide field image.
No, but you need a dark sky to do it.
Huh?
You need a dark sky to do it.
Well, yeah, but I know, heck, back in the days of film, I caught it with a normal lens.
Yeah.
Just running piggyback. It wasn't hard to do.
No, as long as you had a dark sky, you could do it. Wow, look at that. There's the Trifid Nebula. I'm going to actually, I'm going to just look at that. That's really pretty. Now, again, the narrowband filter shows us all this extra detail in here. You can see remarkable convolutions in this nebula that Oh, and I'm seeing that we have a little bit of a guide error there too. Yep.
Mark, would you excuse me for a moment, please?
Sure thing.
Be right back.
All right. I'm going to take us back into the computer. Okay, 7 down. Go down again, and we're going to enter this area here, and we're going to say, let's try this. Okay, and then we're going to make sure that this is done as well. It was before, but we're going to try it again, just to make sure. All right. What I've done is I've actually changed the guiding modes to see if we can get a better image here. Because you see these dashes? Those are supposed to be dots. Yeah, those are supposed to be dots. And they're not dots. So I might be over guiding in this axis, this direction. And if I am, I just remove that by dropping the amount of the guiding down. And it automatically does what it automatically will do it. So we'll see what happens. Okay, I'm going to actually also bring us over here. You're back?
I'm back.
All right. There we go. Okay, let's hope this comes in better. And then we'll look at, I think we should look at measure 11 while we're here, don't you think?
Sure.
Then Isabella wants to see the bubble nebula.
Uh-huh.
And I think the bubble is going to be well placed. So let's just go look. The Andromeda Galaxy is also up, but it's not high enough to be, well, it's about 38 degrees, not bad. What do we got here? Oh, is that looking better? Yeah, we got a little guiding error there. Again, noise is in the image, but we get rid of the noise. One more try. I think that we're almost there. See, telescopes have what's called periodic error, and that periodic error is something that will crop up now and then, and every few minutes it happens again, because it's a small worm gear that's going around in there, and at the same point on the gear you'll see an error occur, and it's a periodic error, and we have to make sure that it gets fixed. We have to make sure that it's not part of it, not part of the image. And we do have periodic error correction in the telescope, and the telescope has been corrected for periodic error. But when you're doing the guiding like we're doing, it really matters. So it still shows up.
It's a mechanical thing.
Yes, it is.
It's imperfections in the surface of the gears.
Yeah. Okay, let's see. This is going to... it's a 1 minute shot, so it'll be coming in, and we want to try and we want to see that we get rid of these little double star images, because they're not... otherwise you think, wow, there's 2 stars right near each other for all the stars. That's not true. So
I have a couple of old, heck, they're still new in the box, but they're old Buyer's worm sets I bought many years ago.
Yeah.
I guess Buyer's went out of business, and I've always wanted to put these things to good use.
Yeah.
Frankly, at this point in my life, I probably never will. I should try to sell them. But they're like, I think they're 8-inch diameter gears, and they come with the matching pinions worms.
Wow.
Probably worth some money to someone.
Yeah, I mean,
I have 2 identical.
Byers was actually a very popular name. I don't know why they went out of business.
Oh, the way of things, I guess.
Hey there, Amal. Thanks for joining us. Ronald, thank you for the link to the Populated Universe. That's a book I wrote that's on exoplanets and the hunt for extraterrestrial life. And it talks about it in terms of things we're seeing tonight, like nebulae, and you know, it takes you down the path of science, but it also is a speculative discussion of the topic as well. So I will speculate, you know, and academia hates when you speculate. Yeah, I don't know why it's doing what it's doing right now. I think maybe it's possible that the guide scope is not getting what it needs. So I'm not happy with that. Okay, so what we'll do is I think we should probably go try to do one more thing here. And that'll test whether we're actually having a problem with the guider or whether we're having I mean, after tonight and all the things that have gone wrong, you guys didn't see it, okay? It was crazy. I was absolutely flabbergasted by how much was going wrong. Okay, we're going to go to this nebula now just to try it out. Okay, so off we go. And you'll see a star again show up.
Is that the Omega Nebula?
It is indeed.
Okay. The Duck Decoy Nebula.
Yes, the Duck Decoy Nebula. That's funny.
Sorry, that's just what I see.
No, that's a very good name for it. It's like the Duck Decoy Nebula.
Well, yeah. Classic astronomers saw the Greek letter Omega.
Yep.
I see a Duck Decoy. And
that's
I
right.
guess, folks, you can see whatever you want to see.
You're absolutely right. You know, there's no doubt about it. No doubt about it. Because people do see what they want to see. Really? Okay, so let's see now. We should be here now. And alright. So once again, I'm just going to back up to the... Yeah, there we are. At least I think we are. Let me check it out. Yeah, we're there. Okay, we're going to do 30 seconds at 10,000 with the narrowband filter. At least I think I left it in narrowband, right? Yeah. So this is 30 seconds of the Omega Nebula, and you will see an amazing difference. Hopefully this nebula will come out perfect. Let's just see. The Omega Nebula is, again, like the Trifid Nebula, is it once was actually a stellar nursery. But from what we can tell, that's really pretty. From what we can tell, all stellar formation has ceased in the Omega Nebula. And you can see it has a lot of convolutions. This is a diffuse cloud, but it's actually got some density to it. You know, if you look in there, there's some density in here. You know, and that's something that's really fascinating to us because we don't know, what might be illuminating those yet. Maybe the stars are inside. Maybe it's this star right here that's doing all of it. You know, and it's so misleading because you're seeing it in 3D. So you don't know whether this star is on the other side of it. You don't know if the stars that are doing it are actually inside this. This is dark nebula in here. It's not an absence of nebula. It's a dark nebula. And it's extended over the bright nebula that's behind it. Same here. There's dark nebula here that's mixed all in this area. So you see only part of the picture. You don't see the entire picture. That's really pretty. That's the Omega Nebula. And Daryl calls it the inverted duck decoy, but I think it would help if I actually show you what that looks like. So there's your duck decoy, Daryl.
Gosh, thanks.
I thought you would appreciate that.
Oh yeah. Carol says she sees a fish, and I could almost see a fish in that.
Yeah. Yeah, that's true.
Tail on the lower left, head of the fish to the upper right.
Yeah. Yeah. There is a fish head nebula.
Uh-huh.
Yeah. Okay. Well, there we go. That came out good. And now what I think we need to do is I need to actually go move the dome now so we can go look at the bubble nebula. And I just got to move us over here so let me get out of here. Yeah. So this is where we're going. We're going to the bubble nebula. And before we go there, I have to move the dome because I can't have the telescope trying to go find something that it can't find because then it'll get all messed up. It'll work, but, it'll just take extra time. I don't want to make it take extra time. So, Daryl, can you hold down the fort while I go move the dome? And
as long as you don't tell me to sing again, yeah.
I won't.
I've already had requests tonight.
Oh, boy. But you don't really sing. You just sort of like talk. I heard you. And went back and listened to the stream.
Well, I thought I was singing.
Okay. All right, folks, I'll be right back. Keep in mind that we will not have to do this in Arizona. In Arizona, the entire roof rolls off the building. And once the Arizona Observatory is up and running, this observatory is getting converted to the very same thing as well. And it might be moved off of this property to a darker site. So we might have a double whammy for you. Anyway, I will be right back, Daryl. Take on the full brunt of all of the many people out there watching.
I'll try.
I'll be right back.
Okie dokie. Hi, Katie. I'm good. How are you? Ooh, Daryl, Carol said. What did I do? I won't sing them. They're OBA, FG, KM. From brightest, hottest, and bluest to smallest, reddest, and dimmest. No trouble, Isabella. I was going to suggest tonight that we go farther up in the Milky Way. Hello, David Schmidt. Fashionably late. Yeah, Katie. I guess nice sunset. Folks, what Katie's referring to, out here in Colorado, we have like 4 or 5, at least 4 major forest fires going on right now. And it has been hot. It's been very hazy and smoky. And sunrises and sunsets have been really spectacular because of that. But the air quality sucks, and the seeing and the transparency of the sky sucks too. When I've gone out the last few nights looking at the sky, you can see the usual bright stars, but even they are much dimmer than usual. The whole sky is kind of wan looking, and dimmer stars like a little Terra Z next to Altair, can't see it at all. And Couldn't see Alberio either. Watching weather maps and stuff, a couple of days ago, the smoke was actually going from Colorado into Nebraska and Kansas, and at one point it looked like the smoke was actually reaching Kansas City all the way over to Missouri. It's been really bad here, and it makes your eyes burn too. Hopefully they get a handle on them soon. They're still uncontrolled the last I knew. Yes, terrible air quality. Go Captain America, welcome. I think the summer monsoon is breaking here, Katie. We may still have some chance of rain, but it seems to have lessened quite a bit recently. We're getting close to Labor Day, and usually post-Labor Day is the best time of year here. We just get day after day, week after week of a clear, sunny weather. Nice mild days and cool nights. Good for observing then too. And yeah, it is still hot here too. It's been getting up in the 90s here. Humidity has been down like single digits. I've seen 6-7% humidity. Just bone dry. Hard on the skin, hard on your hair. Welcome back, David. And they say we're in a drought again here, too.
All right.
Welcome back.
Thanks. I just want to do a finder image, make sure we got it. I do this every time. Let's try 15 seconds at 10,000. Hey, Dave Schmidt, Katie Q, and Go Captain America. How you guys doing? Did you answer Isabella's question about Dark Nebula?
I must have missed it.
Okay.
Oh, what is a Dark Nebula? Isabella, Dark Nebulas, much like what Ronald asked earlier about the dark lanes we saw in the lagoon. Dark nebulas are clouds of dust. They're kind of sooty often. Probably got carbon in them. I mentioned before an astronomer named Barnard, the guy for whom Barnard's star is named after. He cataloged a bunch of dark nebulas. They're known as Barnard or B objects in the sky. And a great example of a dark nebula is the Pipe Nebula, which sits over Scorpius on the west side of the Milky Way, back where we just were. It's so big you can't get it in a telescope. You have to take a wide field shot like with a normal lens on a camera to see it. But he cataloged a bunch of them all over the sky. They do tend to concentrate down toward the Milky Way, especially down toward the center of the galaxy.
Very nice explanation.
I hope so.
Yeah.
Short and sweet.
Okay, this is... okay, there's the bubble in... with the wide... with the narrowband filter. And what I'll do is... I'm going to go back and take it now with the other filter. And we want to also... It's also not quite in focus. I can see that. So I'm going to go back, change over to the correct, the filter I want to use actually. Change to filter wheel 2, filter 2. And let's go focus this a little more. Okay. Let's first of all give you what you want to see. Now we'll do this. We'll get the focus mode up and bring the star up into the center of the focus range and focus. It's out. I'll go in. That might be it. All right, and this is filter wheel 2. Let's do 30 seconds at 12,800 right here. Hello, Trish D. Yes, Isabella Darrow was correct about Dark Nebula. They're actually the result of many stellar explosions. In the end, you get a lot of dust. The dust is really kind of strange, too. It's not like dust that you have on the Earth. They're little micron-sized spindle particles of dust, which are really kind of odd-looking. And the dust itself makes a really interesting, I guess, it becomes an interesting blocker to the material in the interstellar medium. This is the bubble nebula right here, and I can see that I still have a little bit of a focus issue. But you can see this beautiful bubble right here, in this area right here. I can explain that in just a second. In the past, we haven't really seen much of this. This is really kind of an exceptional view. And let me just focus one more time and get us a little closer to what we want to see. This is going to be really pretty.
Yeah. Looks kind of like an eye.
I know it, huh? If you guys like what you're seeing, just hit that like, hit that, smash the like button and let us know what you think. Because we are certainly having a good time with you. So hopefully you're having a good time with us. I would very much like to know what you think. It's not like I can quit my day job. This is my day job. That's not true. All right, let's see about this. Okay, out of focus and come back down into focus.
Where you were getting a tracking error.
Yeah.
Earlier, I think especially on the Eagle, perhaps. Could it be a matter that as you move north, the angle would be the same, but the actual spacing gets to be less because you're farther north, You're sweeping a greater arc when you're closer to the celestial equator.
That's correct, but I went from the Eagle to the Omega Nebula.
Oh, right, the Omega.
And
yeah.
it didn't have any problems. So I think that I was getting some partially obscured partially obscured dome issues.
I see.
Okay, let's try this. Okay. I think that's what it was. Oh, Cheryl, Texas. The horse head is beautiful, and I took a picture out in Arizona of the horse head with my regular camera, just mounted on a tripod. And what I got was absolutely astonishing. It was really, really pretty. And again, this will be from our Dark Sky site for SkyTour LiveStream here coming up. All right, let me just go over here just a sec. All right. Oh, I think we got better focus. Yes, we did. Holy cow, this is nice. Okay. Let's do this. Yeah, look at this. Holy cow. You want to see it? How about if I show you? Okay. Okay, Isabella, this is for you. This is the Bubble Nebula. There it is. Now, what's going on here? Well, this star in the middle this hot star is actually blowing with its stellar winds. It's blowing hot gases that it has ionized. That's why they're red. They're showing up as red away from it. And this would have been a sphere, all right, except here it ran into a denser part of the interstellar medium. There's a dark nebula in here, and you can see it, actually. And the density that it ran into caused it to pile up. And, of course, that made it hotter and thus ionized more gas, which is why it's even more red. So we're actually seeing it. We're seeing it now like this. So you can see how this moves around and goes, but you know, it would have actually moved outward. This star, I don't believe is the one that's actually causing it. I think it's a star like down here that is actually causing it. This is a field star, one that's sort of superimposed. And we're looking at the result of something called a Wolf-Rayet star, which is a very, very hot star. And it is actually causing this nebula that we're seeing here.
I was about to ask if it was a Wolf-Rayet star.
Yeah, exactly. And then there's another one that's very famous in the winter that we've seen.
Thor's helmet.
You got it. It's Thor's helmet. It's another one, Isabella, which is actually a Wolf-Rayet star, which is actually blowing a two-lobed, multi-lobed shell around the star. This is a shell that's more than one shell, but let me see if we can actually go back and take take our 1 minute or 1 minute and a half photo. And again, this will be at that amazing 12,800. So this is beautiful, and you look at this, and you say, "Wow, we might be looking at planets around some of these stars that we don't even know are there." But we know there's nothing here that supports life, because the Wolf-Rayet star that's causing this bubble is so hot that the radiation it puts out would definitely extinguish any life. And just for the record, it probably didn't kill anything, okay? It's probably just not been life-bearing at this point. Someday it might be. The Wolf-Rayet star may end up going supernova. Or it may cause what looks like a planetary nebula. You know, like the Dumbbell Nebula that we've seen, or the Ring Nebula. All right? But this nebula here is definitely a odd structure. It's a really odd creature, but it's just beautiful. And I want to thank you, Isabella, for suggesting it. It was up, and that's what SkyTour LiveStream is all about. Take your requests, you know. Now, if the dome wasn't there and we could just look anywhere in the sky, oh gosh, it'd be so much easier, you know. Okay, this may be pretty interesting. Let's find out. Yeah, look at that. This is a 1.5 minute shot. It's got a little drag to it, unfortunately. I'll take another shot. I didn't tune the guider assembly tonight because it was I ended up having all these issues with the telescope tonight. I don't know why. I have no idea why it just started misbehaving.
See a little more nebulosity above the,
up here, yeah.
Bubble.
Yeah. Yes, sirree. You can see the whole images here, and I don't have room to put it all on here unless I actually just shrink it down. You know, but I'd rather split the difference and then just bring it up. But then this gets cut off down here. And I don't want that to happen either. So either... Well, I can figure it out. You know what I can do? I can just move it over.
David Schmidt, I'm afraid the sombrero is gone.
Yeah.
For the season. It's west of Spica, and Spica is surely set for Mark by now. It's probably setting for me too by now.
I think so.
Spica in Virgo, that is. If you go out and you see the Big Dipper and you follow the curve of the handle of the Big Dipper, you'll see the bright spring summer star Arcturus. If you keep following that curve down, you'll come across the star Spica in Virgo, and the sombrero is just to the west of Spica. And Spica is pretty much set for the season now. I think this late at any rate. You can still see it early on in the evening, but it sets pretty soon after now.
Thank you, David. That was a good question. And thank you, Daryl, for answering it.
Sure.
Okay, I'm going to go to the narrowband filter and jump up here 2 stops, go up to 20,000 and go for that 1.5 minutes and see if we can get a nice shot. Now, we're noticing here in the bubble, you can see this additional nebula up here. And I'm going to try to pull out a little more detail in here, especially in here. I'm going to try and grab detail in here. I'm glad you like the bubble, Isabella. It's it's very distended too. I mean, this nebula here is going out light years from the star that created it, which may be this star here. Again, you're tempted to think the big bright one caused it, but it's not that one. It might be this one. I have to check. I have to see, make sure. But it's really beautiful, and that star is also so hot that it's causing this gas to glow up here as well, light years away from the star. So that's how hot these stars are. No, Ronald. Ronald asked the question, are all the nebula of the same age? No, they're not. No, they're not. The nebula are not all the same age. They may very well be significantly different ages, as a matter of fact. Okay, so this is interesting. You can actually see, well, tracking error, darn it all. Okay, another shot. You know,
the high contrast of that filter kind of helped bring out the bubble. It looks like it may have lost the fainter part of that nebulosity we saw before, though.
Well, it's here anyway. That's this here, and then there's more out here that would undoubtedly come in with a longer exposure. But there's a tracking error here that I don't like, so I'm trying to figure that out. Actually, I think I might know what the problem is, and I have to wait for this exposure to be done, and I will make the adjustment.
Daisy and Zoe have good taste. Glad to share it with you.
Well, we didn't see the butterfly nebula. We saw the butterfly cluster.
Oh, I'm sorry. Okay, my bad. Still have good taste.
Yeah, they do. Daisy and Zoe and Lane, of course. Don't forget Lane. Lane joins them now and then. You should put it up on the big TV, in your living room if you can. And I think there's other people that have done that. They put it up on the big screen and they sit back and watch like it's an interactive movie that they have a part in, And that's really kind of what it's like, You guys do have a part in it, Wow. Now that looks nice. Let's do this.
That is nice.
A little processing there. So you can see now this is what I want to get at. You can see how it's not just a smooth bubble here, Isabella. It's actually got a lot of areas inside the bubble which are actually denser and not quite as dense. In other words, there's an awful lot of material in here that is undergoing all kinds of changes. If you saw this in a Hubble image, I imagine that you would see this looking like this beautiful wispy structure, kind of like a wispiest of clouds, but stunning nonetheless. Really, really pretty. Yeah.
That's a nice image.
Yeah, so thank you for steering us this way, Isabella. Really nice. I'll take another shot, see if we can get another couple like that, and then maybe I can stack those and make them available to Isabella and everybody. So let's go back here.
That really pulled out the brighter red and
yeah,
there to the lower right of the bubble.
Yeah, it did. And this is the raw file. And again, I'll get rid of all the noise in here. The noise looks like stars, but it's not. Okay. And I can get rid of that noise, and that's really helpful to do that. But a little instant processing, and you can actually see that it's how it's gonna look a little bit better. This is not even quite the same. All right. That's really pretty. You can see the density changes in here. Really pretty. Let's see how the next one comes out here. Now, ideally, if we're doing these in a even more professional manner than we're doing them, what you would do is okay, this is going to be a little screwed up too. Oh, I know what I was going to do. That's what I meant to do. I was going to correct for that. I think I can correct that. If you're going to do this more professionally, what you might do is take this ISO from 20,000 down to more like 6,400, and instead of a minute or a minute and a half shooting, you would shoot it each one for like 12 minutes at a shot. And then do like 20 of those over the course of a season. And then stack all those. But that's something that I would never make you sit through. Now there's research nights where I'll just open up the stream and say, hey, it's research night, you know, you're gonna watch me doing stuff in the dome. That's gonna be maybe boring to some, but at least you see what real astronomy looks like from now and then. Let's see. I am going to, now that I'm not taking a picture, I'm going to go into, first of all, let me just get the computer zeroed out, go here, go down there, and this is the one I want right here. There we go. Now let's do this again and see if that worked. What I did was I changed the guiding rate in the east-west motion, because that was the one that was messing up. So when we look at this again, all right, and we come back to the east-west motion is being messed with. This is north-south, this is east-west. Actually, that might be north-south, because this was actually like this before. But the telescope, the way it's sitting, it might be on that steep angle. So we'll still do what we're doing and see what we get. So are you guys enjoying SkyTour LiveStream?
I think they are. Lots of positive comments.
Yeah, well, the people are really enjoy it. They think they enjoy it. That's good stuff. A lot of fun. I feel real bad that we didn't get off on time tonight.
Well, don't beat yourself up.
You will,
like I said before, you can thank Bill Gates.
Yeah, the computer really nailed me good on this one. Yeah, see, look, this looks so much nicer.
It does.
The guiding is better. I actually had to make a subtle change to the guider, and it looks like... is this the same one, or is this a different one? Let me see. Okay, yeah, that's a new one. All right, so I'll take another one. All right. Looks better.
Mark, your music volume seems to be changing constantly. Gets loud, gets quiet, gets loud, gets quiet.
That's funny because I have an auto limiter on it that sets it to the same volume.
Maybe it's me.
Your ears get louder and dimmer and louder. No.
Maybe it's Skype.
Yeah, I'm not sure, but I don't...
I think I have the auto adjust turned off, but I just hear it getting loud and dim, loud and dim.
Well, maybe they do too. You know, you could be talking for the throngs of the masses. All right, let's see how this one comes out. Let's see if we have made it a little better. Yeah, you can see all these beautiful convolutions here in the bubble. You can see all this detail in here. That's a narrowband filter for you. It really does a really good job. All right, all right, here we go. Oh, this is gonna be a beautiful shot. Yeah, this is a really nice shot. This is no guiding error here. Yeah, look at that. Oh, that's really pretty. Really pretty. Oh, yeah. Cool. Let's see, now while we're here in this region of the cosmos, let's find out if there's something else we want to see. Yeah. You want to see anything in particular while you're here, Daryl?
I haven't looked at the veil in a while. You're up in that general part of the sky.
That's correct. The veil is directly up here. Actually, that's amazing because the Gamma Cygni Nebula and Solder is right there, and we've got the veil. I think right. Oh, there's a Crescent Nebula too. Oh, we have all these beautiful nebulae to look at, and I don't know where to go. But you said veil, so I think that's a good idea. We're gonna check out the veil. All right, the veil is a supernova remnant, the remnant of a amazing supernova that went off about 1,600 years ago. And it was really moving outward at I think it's 1,600 light years away. And I think it happened within 10,000 years or so. Well, let's try it. Let's see if we can go there, and let's see if the telescope will align. It's looking quite high up there, but let's see if we can bring up our telescopic view. And all right, well, I guess not yet.
But the narrow band works well on it.
It will. It will indeed. Okay, we may have Might work. All right. Might work. Okay, you can see where the telescope's looking now. And if you have eagle eyes, you can actually see that it's moving. Alright, so now we'll come back here. And we are on the narrow band. So we have to wait for it to be in position. I'm going to just go down to the, this white light shot. It's slightly out of focus, of course, but I want to do the white light shot just so we can see where we are. And I believe it thinks it's there, so we should check it out. So let's go back to the narrow band. I'm going to go with the slightly wider narrow band to begin with. And,
good idea.
And then we'll just do a do 30 seconds at 20,000 on this. Okay, here we go. We should have our guide start right now. For those that are repeat offenders here at SkyTour LiveStream and keep coming back, we appreciate it, of course. My operation cam is down at the moment, but that's a darn sight better than the whole telescope being down at the moment, because that's what was happening earlier. Wow. Oh. Wow. This is beautiful, Daryl. Look at this supernova remnant. Look at that. That is just beautiful. Notice the blues. Notice the gossamer strands. Some blues and some reds. Remember, the supernova occurred out here somewhere, and then just the stuff blew outward. And as it went outward, it expanded. And as it struck other areas in the interstellar medium, it actually ended up sparking other things to happen. Potentially some more star formation. Because the shock waves on such a massive scale from a supernova can actually cause star formation, as long as it runs into material that it's pushing along like a snowplow and makes it dense. Then it starts to coalesce and gravitationally compact, and next thing you know, we're looking at stars potentially. So this is really pretty. Look at that. Oh, that's really gorgeous. Little processing here for you. Okay, I'm gonna good suggestion, Daryl. Good suggestion.
Well, that time of year.
Yeah. Now we're gonna go up to 1 minute at 20,000. Wait, is that 1 minute or a minute and a half? It felt like a minute and a half to me. And it was a minute and a half. Okay, so we're gonna drop it down to a minute, so we don't have to wait so long. Minute and 20,000. This is with filter number 2, the wider narrowband filter. So here we go. Yeah, David Schmidt. It's, I don't know. The thing about the notifications has been broken at YouTube's end, because people will say they're not getting notifications, and they're right, they're not. But it's not anything other than just some kind of bug in the system.
I often get them like 3 hours late.
Yeah.
I still haven't received a notification for this stream for tonight.
Really?
Yeah, I have the same problem with Bill streams too.
I didn't even get a notification that I was live, so I might not even be live now, and all these people might be an illusion. Look at this! Wow! Look at this.
That's nice. See
Look
a little
at
more
that.
color in it too.
Yeah, the longer you go, the color comes in. Okay, folks, this is a true supernova remnant. This is beautiful. You can see this gorgeous gossamer tendril as it's going up here and over, and we can actually get over to 52 Cygni, which is the star on the other side of this. Okay, in other words, this way, out this way.
You read my mind.
Did I now?
Yep.
And
that's where the witch's broom is, right?
Yes. So yeah, look at this beautiful supernova remnant, absolutely stunning. Oh, and the guiding is actually quite good here. So I think I'm gonna just do one other thing here. I'm gonna take back what I said about a minute and a half, and I'm gonna actually do a minute and a half. Okay. And then we'll go do the other one. This is beautiful. Oh yes, that's really pretty. Wow. And I would use this one, which is the raw file, to actually do processing. Might have a tiny bit of dome down here. You notice a little reddish. Might be just a little bit of a interference there, but not enough to be dangerous. Check this out. Look at this spot here, guys. Here's a star, and you can see how it's actually illuminating part of this nebula here. Now it's not causing this stuff to glow, it's just illuminating, and the star is white, so it's reflecting off these dust clouds here, and it's coming in as white. And yes, dust. There's dust in this nebula. I'm sorry, in this supernova remnant as well. Dust that was made in the supernova, and dust that was made at the surface of the star before it exploded. Oh yeah. Boy, this is really pretty. Look at this gossamer. Wow, look at that. Holy cow.
That's nice.
Even more little processing here. Look at this. Even more color showing up.
Mm-hmm.
Yeah, this is really nice. That's really, really nice. So let's go over now to the other side. And that's going to be 52 Cygni. And we may not even have to... do much. We might be able to actually just head over there directly. Let me see if I can steer us over there. So to do that, I'm going to have us go a little bit faster. And now head the other way. All right. And you'll see the stars going by. Oops. All right, and you'll know where we're supposed to be when you see this star right here come in. When this star comes in, you'll know that we're getting there. So first of all, let me get rid of this. And now let's go over here. And you'll see 52 Cygni come into the view. And there it is. Okay. So now there's another remnant here that's sticking up here, and you can't see it yet. But I would like you to see it. So I'm going to do another exposure at 20,000 and a minute and a half. But we're going to let the telescope settle in and find its guide star first. We need that to happen first. And the telescope's actually pointing a little bit more away from the dome slot, so this will be a very nice location for us. Okay, let's do it. A minute and a half at 20,000 on the other side of the supernova. And just while we're waiting, I'll show you a little more about that. So when we are actually looking at the supernova, we can see that the supernova remnant is here. And we notice that somewhere in the middle is the location where the progenitor was, the star that exploded. This was blown out, this was blown out, this was blown out, and this was blown out. You'll notice it predominantly was blown out in this direction and this direction. And the north and south parts were less so. That might have been the way the interstellar medium was laid out in terms of density, or it might have been for other reasons. But it really was something that was non-homogeneous. It was actually kind of different all around, you know. Wait till you see this. This stuff here was actually, this was put into a very, very tight spindle compared to this gossamer thing. You look at this, it's going to be a little bit different, as we'll see here in a moment when we come back. Here we go. And there is the gossamer other side of this. Isn't that amazing? This is the star 52 Cygni, a field star. Look at that. This stuff was bunched up. It was bunched up. That's beautiful. And if we go down lower, then we can actually see more detail down below. We can do that. What did you think of that, Daryl?
Oh, I thought that was great.
All right. So now we're going to come down a little bit here. I'm going to slow down the telescope a little in terms of the speed at which it moves.
KDQ, I think Mark said a little while ago that it's about 1,600 light years away.
And we can confirm that. Let me just see. I'll go back in here.
All that there, that is the witch's broom, right?
Yes, the part that I'm looking at.
Okay.
Yeah, this program reports around 1,500 light years away, but you know what? It doesn't matter. It's any port in a storm. It's close. Okay, let's just...
Ronald asked, why is it in a line like that? I assume because that's the wavefront.
Yeah, if you look at ocean waves, you know, when they are going through the ocean, they're big, long rollers, but when they get to the shore, they break, don't they? That's because there's resistance to the water, and the water starts piling up. Same thing happens on the front of a snowplow when a snowplow is plowing a snow, like in Ronald's hometown, where they get snow 9 times out of 10 throughout the year. And so as the plow is pushing, the snow gets accumulated on the front of that plow. Well, think of the snowplow image as what's happening in the interstellar medium too, but in 3 dimensions too. And so we see this happen as well. We watch this star stuff getting accumulated on the front of the plow, and as it's trying to, and the plow is the force of the supernova explosion pushing this stuff out. Well, as that material is moving into the interstellar medium, when it hits something that is dense or resistive, or resistance, offers resistance, it'll slow down a little, and then the stuff behind it, still moving faster, will catch up. And the overall effect is that over time, it'll all bunch up. And that's really kind of what we're talking about here, is it's sort of bunching up along this line, coming from this direction, going this way, and it's bunching up. So there's something here that slowed it down, probably a density of stuff here that slowed this down. This kept going a little bit faster, but it was all generally hitting something of higher density here, which started slowing it down, and thus it bunched up like this. So
I think it's interesting when you look at that, the upper part of it, you can see a brighter blue line there.
Right here?
Yeah, right there, and a little above that. Like maybe that's where the compression's going on.
Certainly is. Certainly is. There's these, and you said it before, these are basically wave fronts. Again, like water, but in a medium that's much less dense.
Yeah.
So this is now below that star. The previous shot, this shot, was above the star, 52 Cygni. Now we take a shot looking below it, and you can see down below there's more. Again, another wavefront right there. Look at that. That is just outrageously cool. Never been able to capture that before. This filter really does make this really shine. Pretty amazing. And actually, we're only doing this. This is on the wider narrowband filter.
Yeah.
I want to go back and take a shot with the extreme narrowband filter. I want to do that now, though. I'll do it with this guy. So I'm going to go back to filter 1 right now. And we will go and take a shot now. And we're going to go to 25,600. We're going to go up a stop and see. It's going to be... it'll be brighter in areas and less bright in others. But it's really amazing how this stuff comes out of the star when it explodes. Initially, it's coming off at some density in all directions. Now, that density could vary depending on the nature of the star's spin rotation rate. The rotation rate could be responsible for why this nebula has a predominance of stuff on one side and the other, but not near the top and bottom. That could cause the equatorial bulge to expand out faster, perhaps, causing what we see. Or not, Now, this is a supernova. The next thing we're going to look at is a planetary nebula. And what's going to be interesting is you're going to see some of the same colors. And they really do mean kind of the same thing, but they're generated in a little bit different ways. So right now, this is the bottom part of this upper part here. It goes down and continues down to here. Now it's hard to see some of the detail in here, but maybe with the filter going up a stop and the same amount of time and a narrow band, we might be able to pick out like this blue line better, for instance. Oh yeah, look at that. Wow.
Wow. That's cool.
So yeah, so see, we're getting more detail, believe it or not. This filter is worth its weight in gold. Practically costs as much. But yeah, look at that. That is really, that's elaborately detailed. Look at this. Look at that. You can see very, very detailed convolutions in there.
Right.
Wow.
This is the narrower.
This is the narrow band. Filter? This is the narrow band filter, yeah.
Okay.
It's called a tri-band filter. It actually looks at sulfur 2, hydrogen alpha, and oxygen 3. Oxygen 3, the O, and Roman numeral 3 is doubly ionized oxygen, because remember the Roman numerals are basically one more than you would actually think it is. So when you see H Roman numeral 2 or HII, that's actually that's singly ionized hydrogen, okay, and you get that, yeah, you're right, and you get that hydrogen alpha from that. But yeah, this is beautiful. Wow.
This is the first time we have seen the veil through these filters.
Absolutely.
Yeah, last year it was the 03 or the Sky Glow, whatever filter, right?
Yeah, and that was actually a close second to this one. Or not even close, but a distant second to this one.
Right.
Yeah. But look at the narrowband shows this really, really detailed. You know, I mean, this is outstanding. Look at this dark nebula in here. You can't miss it. This is really outstanding. Wow. I need to go back to the other part of the veil now and take a picture with this again. So we'll do that. So we're here and we're going to go over there again. Let's tell the computer we're going to go fast again. Go fast. Go fast. And we just have to head toward the east. Or the west. No, east. Okay. Alrighty, and now we'll go up. Okay.
Mark, while you're doing that, can you scroll back a little bit in Stellaria? Just to see the cross or the swan.
Yep.
That's one of the wings right there. That's one of the wings of Cygnus the Swan, you see?
Yep, there he is.
And the veil is right under the wing.
Exactly so.
Okay, thank you for indulging me.
Not at all. Not at all. Okay, so now we should have our guide star and we should be back on target right here. Let's go check this out. Here we go. I'm so excited. Gosh, that's so exciting. This is so cool. I mean, look at this detail. Wow. I'll tell you, if I was making this a private session, guys, I would have just taken probably 30 photos of this length, just of this one section right here, and then stacked just this one section right here.
Can you zoom in on 52 Cygni a little bit?
Yeah, because you got that up there too.
Right. Well, I was wondering, there's another tendril hanging right there.
Yeah.
Right there.
Yeah, and in this other shot of 52 Cygni, we can see that as well. All right. And you see it in a little better color, but it's not as detailed as here. Okay, here it actually has more detail.
Yeah. Such a sharp, thin line. That's amazing.
Yeah. That's definitely a shock front.
Right.
We call it a shock front. Boy, that's beautiful. And now let's see, we're doing just this other one. Okay, there you can see the JPEG compression causes it to change a little color, and the raw file doesn't change the color at all. We just have to process away the noise. Wow. Look at this. Look at that. Look at that. It's beautiful. You can see how... Look at the complexity in there. Man, it's like looking at smoke. You know? Really is beautiful. Yeah, I want to look at the dumbbell. Don't you want to look at the dumbbell?
Sure.
Oh, yeah. So that was great, guys. I really like that. And, you know... these photos I'll make available to you, by the way, so you understand. It's not the last time you're going to see them. Okay, this is not the one. That's the little ring. And the dumbbell is right around here somewhere. I don't know if that's it.
Right there. Nope. Over to the left. Over to the right.
Right here. Duh. Here it is. Okay, we're going to go there. And let's go check out what the telescope thinks it's doing.
Dumbbell is in Vulpecula, right?
Yeah.
I think. Yeah,
Yes,
I
it
just
is.
saw Vulpecula there.
It is. Okay.
It's right under the cross or Cygnus, and
yeah.
Vulpecula means the little fox.
Yep. And it's right near my favorite double star, which is what it uses as a high precision pointing location, which is Albireo. I may have to move the dome a little bit. Darn it all, but hey, you know, it's okay.
Take care, David.
See you, David. Very nice. And let's go see what the telescope is doing in terms of the we might be okay. I'm not sure. We might be all right. Let's find out. And we'll just do a short photo. I'll do 20 seconds at 25,000. No, 15 seconds at 25,600, just to make sure we captured it. I think I see it actually in this view already, but we should be okay now. So let's go. 15 quickest seconds. This will be the Dumbbell Nebula.
This is the one I always think of as the Apple Core Nebula.
That's right. That's it. Dead center. And we're looking at it with the narrowband filter too. Yep. All right. So that's good, and we don't have any problems. So what I will do is I'm going to go right up to 1.5 minutes on this at 25,600, just to see how well it looks, and then we can check out and see if the if this will have a counterpart image that will look really good too, just like the other one. Again, this is the raw image right here. You'll notice in the raw image, you see this. See how this complexity comes out here? But when you have the JPEG, look what happens. See, it gets softened and some of it gets lost. That's what happens. It takes similar colors and it tends to make the colors around those more like those colors, averaging in a sense. Okay. And this was really pretty. You know, when we look at this is gorgeous. Okay, with a little bit of processing, looks good. 52 Cygni was beautiful with this extra. Look at that. The wisps are just so beautiful. Down here, look at this. This is a really beautiful area down here.
Uh-huh.
What I wouldn't give to be there to look at what's going on right now. Wow. I'd love to see that. Oh, hey, that didn't work. Okay. Periodic error. But you notice that as soon as you get in with longer exposures, you do get a much better rendering of the color. Yes, Terra, blue. The blue color is the oxygen 3, that is the O III, or the O Roman numeral 3, doubly ionized oxygen. So you have 2 electrons that are ionized off of the oxygen atom, and when they come back into the atom in a process called recombination, they will reach a particular state more often than any other state, and that particular state gives off this bluish green or teal color. Kind of interesting, you know, because you don't ever see green stars. So you say, why should I see a greenish blue nebula? And it's because it's an atomic transition that results in this color, not the heat and radiation of the stellar furnace that's going to eventually cause that. I always thought that was kind of an interesting observation, you know. Okay, I want to see the next one come in better. Okay. A little better. Still got a little walk going on. That was probably that's probably the end of the periodic error. Let's do 30 seconds at 25,600. So it'll be 1/3 of the time, so it'll be a little dimmer. But it should be good.
Mark, excuse me for just a moment, please.
Sure thing. Wow. That's really pretty. This star right here, that remaining star right there, that's the guy that caused all this. And what's left in the middle there is a white dwarf. Very, very hot at the surface. 45,000 Kelvin. And it's so hot, in fact, that it's actually causing ionization of the oxygen atoms in this nebula. That is the outer shell of the star that used to formerly be attached to this guy. And then this area here as well, the redder areas, these are areas that have been similarly affected by this star's radiation, and now those are also been ionized and they're recombining. You notice the size of the dumbbell is not just this apple core, but it actually goes all the way around. But it does seem to be predominantly up this way and down that way, doesn't it? Now it could be that the star was rotating that way, and that actually the South Pole might be here, or the North Pole might be there, or vice versa. This could have been the South Pole, this could have been the North Pole, and it was spinning this way, and this stuff was spewing off over time to form this expanding nebula of that actually shows that it's in the middle of the death throes of the star, because the white dwarf stage is the last stage. Okay, let's see. I'm gonna try and go. Let's go and go back up to the settings here. We're gonna do 1 minute. Okay. And we'll do a 1 minute shot. Okay, and then we're going to see how the 1 minute shot. This is 30 seconds. We're going to do 1 minute now. Yes, indeed. How many of you heard SkyTour Radio, our radio show Sunday night? I did the first 10 minutes of my written show, and the rest was all answering questions from you guys. And I thought that was really good. And Amanda, she wasn't here tonight, unfortunately, but Amanda said it was a beautiful show. She really liked it. And I did too. It's fun when you guys are so into it that you want to ask questions. I love it. Oh.
Very nice. Very nice.
Yeah, we gotta have to do a little better on this.
Well, I like it anyway.
Oh, it's really pretty. Yeah, the 30-second shot came out okay, see?
Anybody else see the apple core?
Yeah. Thank you, Carol.
And maybe that shows you why they call these planetary nebulas. If you see that in the eyepiece, it's generally smaller, and it looks almost like a ghost planet floating out there.
That's right. So Daryl's alluding to the fact that it looks like it could have been a planet, and therefore we call it a planetary nebula. Planetary, over like a planet. But we know it's not really a planet.
Uh-huh.
Yeah. We're getting better. Once again, I think I took a picture that was in the middle of the periodic era. Yeah, this is something else. The other thing that's interesting is this is a fairly large nebula in our sky. It's actually one of the closer planetary nebulas to us. So we have the opportunity to study this and look at the details of this planetary nebula. Very much unlike others because this one's closer. That's why it's so large in the sky.
Have you ever tried to image the Helix Nebula?
I knew you were going to ask about the Helix. Yes, I did. In fact, I got a beautiful image of the Helix. But it's so low on the horizon here that it doesn't really do it justice. But it does, actually, the Helix does show up here. But in Arizona, it's going to actually be higher in the sky and might really, really be pretty. Here's a better shot. Look at this. So now we're looking at some details of this nebula. Look at the dark and light areas. You can see the density of the gas, the knots. You can see the central star right there. All right. Now, really, again, once we remove the noise, it's going to be looking a little bit more like this. I mean, just a bit. We'll actually be able to see it a little better. But look at that, huh? That's a beautiful nebula, Daryl.
Yes, it is.
And what's interesting is, if you notice, many times when we've taken pictures of the dumbbell, we don't actually see the entire thing. We always see it kind of like the hourglass shape that we're familiar with, because that's all we're exposing for. You know, but it really is looking pretty. Looks downright gorgeous. I like the dumbbell, and so that's a planetary nebula. It's the end of a star that's different from what we saw when we were looking over at this. Okay, this is the end of a star that's caused by a stellar explosion. All right. When we look at a nebula like this, for instance, here we're seeing a star who can't fuse hydrogen into helium anymore, or who runs out of other fuels to fuse in its core. And when that happens, the core just suddenly stops fusing, and now the gravity of all the overlying mass bears down on that core for all it's worth, because there's nothing to stop it now. The outward pressure of the fusion before was stopping it, and now, with nothing to stop it, that entire mass of the star hits the core of the star and rebounds off of it. And many things happen during that process, including the making of more elements in the periodic table, as well as a massive explosion that causes a huge shockwave in the interstellar medium to go out from the point of origin. Now, in terms of what happens in the world of planetary nebula like this one? Well, here, this is a slow process. These were the former outer layers of a large red giant star, and they were sloughed off slowly, and then they finally became gravitationally unbound. I should say unbound gravitationally to the star, because they were so far away from the star, just like Betelgeuse would be well beyond Mars' orbit, almost to Jupiter here. And when we look at the outer layers on Betelgeuse, there's no reason to expect that they were going to just stick around in the interior of Betelgeuse, because when Betelgeuse's outward radiative pressure is pushing these things out, way out by Mars or Jupiter, there's really not a whole lot that's going to be keeping them attached to the star. The slightest outward force could cause them to be liberated from the star. And that's what happens with these. This was a former red giant, and the outer layers were pushed off that way. And this is what happens, and what built up over time. Over hundreds of thousands of years, perhaps millions of years, this is what built up. And that's where planetaries come from, and they're very different. They're quiet ways to die versus the supernova, which is a the massive explosion of the cosmos. So in any case, that is really cool. So I hope you enjoyed that little foray into the Dumbbell Nebula.
Nicely done.
Yeah, it's beautiful, huh?
Speaking of Betelgeuse, James Dugan, I think, mentioned earlier, Betelgeuse and Orion are back up in the morning sky now. And in fact, Sirius is up also, but he says Betelgeuse is dimming again.
Is it? I haven't been following that. It could be. Man, I'd be so excited if it was going to be a supernova. I'd be up all night, and I'd be having this thing trained on Betelgeuse, and we would be taking all kinds of images with all kinds of filters. I'd hook up the spectrometer carefully and quickly and get some spectral data to see if we can register anything coming off of Betelgeuse that shouldn't be there. Oh yeah, that would be so cool.
Yeah.
Oh yeah. Wow.
There's Sagittar the Arrow.
Yeah, Sagittar, yeah. Yep. And there's a little globular cluster right here, too. Let's try that. Alright, and I'm going to actually, just for purposes of doing what we're doing, I'm going to go to filter 2. Alright. Okay, it's going to Altair. I see a little spicule on top of Altair, which means that the dome's in the way, which could explain why it did what it just did. But luckily, it still found it in Sagittar. Alright, now we should be able to see the globular cluster. It'll be faint. It's a faint one, but it is up top. You know what I want to look at, don't you?
The ring?
No.
Oh.
I don't want to look at the ring. No. I don't want to look at the ring. I don't want to look at Alberio.
Cat's eye?
We have the cat's eye. Yep. I'll have to move the dome again, but that's okay. And another thing to look at as well, we have the Iris Nebula over there. But we also have Let's see. Let's go over. Where is... Okay. Well, first of all, we're here now. And let's just take a 30-second shot at 25,600 of this globular cluster in Sagitta. Sagitta.
I say Sagitta.
Yeah. A lot of people.
Like Sagittarius.
Yeah. A lot of people do.
But Sagittarius did not shoot Sagitta.
That's right.
Bow's pointing in the other direction.
Yep.
Here comes the stars of fall, folks.
Yeah, that's right.
Capella's up for you, Perseus, Andromeda.
Yeah, I was thinking of Andromeda, frankly. Let's go see the globular. In the winter Milky Way.
See a little red. Is that the dome?
No, that's actually probably some of the Milky Way nebula. The dome is not in the way. Down the bottom, that's actually amplifier noise. Okay. Wowee. Did it not go there? You know, sometimes when you mess around, it can screw things up. And there's the Heart and Soul nebulas too. And the double cluster. I would like to show people the double cluster. Double cluster is really pretty, but it's, I think these are kind of low now. Really pretty though. Yeah, I don't think we actually... I think we had a alignment issue. It couldn't find... It didn't go to the this particular location. Yeah, and it could have been because the dome was in the way. I have to check and see where it is. And let me see. Yeah.
Katie, the story of Sagittarius, I don't remember all the myth offhand. I'd have to look it up. You know, the mythology of it. What we see as a teapot, back in the past, they saw as a half man, half horse shooting a bow and arrow. That's all I can tell you offhand.
A centaur.
Right, centaur.
Okay, let me try something here.
Interestingly, there are two centaurs in the sky. Down to the southwest of Sagittarius, actually below Virgo, I think, you have Centaurus.
That's right.
Kentaurus, they might have said at one time.
Because it was started with it was spelled with a K instead of a C.
Yeah.
Like Rigel Kent. I'm driving the scope. Oh, see, I did it again to you guys. I put that up in there. All right. Just driving to this object. just to see if maybe there was a problem with the way the high precision pointing attached to it. I mean, it went to a star that was really not a good star for guiding because it was blocked by the dome a little bit.
I thought I could see that in the dome cam. It looked like it was impinging on one side pretty badly.
It was. You are right. You have spoken wisely. And we'll see if I'm right. Okay, so technically we should see a globular cluster in here. If I take this picture, so we're gonna wait for it to catch up. But we might have an issue with the dome. See that?
Yes.
If we could, maybe not. Okay.
Oh, sorry.
That's okay. All right, we're gonna do 30 seconds at 25,600 right here and now to see if we can see this globular cluster. But then, regardless, we're gonna move to another object. Which object, you might say? Aha! I'm glad you asked. Because we are in the neighborhood of the Cygnus Milky Way. And it really is a beautiful night, and I don't want to waste it. There is... let's go see here. Oh, yeah, there's the globular cluster down there. But we did have a little issue, but you'll notice that the guider is not perfectly lined up. And we do have an edge of the dome getting into the view. So let me just decide what I'm going to do here. Where am I going to go? What I would like to show you... Why don't we do that? Yeah. Let's go see the crescent. I think we can do that.
It's the one I goofed on earlier.
That's okay. I know what you meant. Okay. You're hearing the telescope move as well, I think. And
that's solder, isn't it?
It is indeed. And this is on the wider narrowband field. Actually, right around solder is the Gamma Cygni Nebula. It's really pretty. I took a wide field view of it, and it was beautiful. Now, the Crescent Nebula is going to be in the same relative spot here in just a minute when it goes zipping away, which will be momentarily. There it goes. And then we're going to be down here at the crescent. Okay. Then we have to wait a few seconds for it to stabilize. That's where we want to be, and now we're going to make sure that it actually gets our guide star. By the way, every now and then you might see a little flash on the screen. There was one just a few seconds ago right about here. This was up at the time. Right here, and there was a flash right there. It was a little flash right there. You might say, was that a camera glitch or whatever? Well, it could be. But there's also another possibility. You could be looking at a meteor that is actually coming right toward you. And that's how they appear, as sort of a little flash in the sky. So that's a possibility. And it's a big planet, so it's possible that could be the case. All right, 30 seconds at 25,600, and we have the Crescent Nebula. That's really pretty. Look at that.
It is.
Yeah. It's almost worth going back here and going up to a minute. Let's do a minute.
Folks, when we look towards Cygnus like we are, also known as the Northern Cross, the tail of the swan is the head of the cross, Deneb. When we look this direction in space, we are basically looking 90 degrees away from galactic center. You can actually do this if you hold your left arm up, point it toward Deneb, and point your right arm toward the spout of the teapot in Sagittarius. You'll see your arms make a right angle, a 90-degree angle.
Yeah.
And so instead of looking toward the center of the Milky Way, we're now looking straight out at the next arm of the spiral galaxy.
That's right. Wow, this is pretty. Look at that.
Wow, that is nice.
Yeah, look at that. Wonder what that is.
Looks almost like a galaxy.
It does, doesn't it?
Yeah.
But I don't think that's a galaxy. Let's find out. I don't see anything there.
Yeah.
Must be artifact, possibly from a reflection. But boy, that's pretty. That's, you can see again this beautiful color. It has multiple colors in this particular nebula. Really cool. This is also known as NGC 6888. And it's being, it's definitely being blown out by winds from that central massive star in the middle. We could be looking at another Wolf-Rayet star here. Okay. At least that's the way we've identified it, is actually a Wolf-Rayet star blowing a bubble. Basically, these stars blow cosmic bubbles. Okay, Thor's helmet, the one we just looked at. Okay, the bubble nebula, and then this. It's not just three. There's many of these out there. But boy, I tell you, it's incidentally, this wisp right here is a real wisp. It's actually associated with a star that's there. It's the first time we've ever seen it, and it took this filter to bring it out. That's actually there. It's not a galaxy at all. It's actually an actual bluish wisp. So that's pretty cool. Alright, let's see. Let's go back and do the normal thing. Let's drop down to our narrowband filter and just take another one. We'll see if we can see those wisps a little bit clearer. Thanks for sticking around, guys. I hope you're having a good time. Okay, so the Crescent Nebula formed by a Wolf-Rayet star. And the other thing is this Crescent Nebula, again, is not... It's... The material was blown off evenly, but some of it continued farther out here, but some of it got held up as it hit a denser part of the interstellar medium. And that's why you see it brighter like this. Okay, so now we come down here. We can actually start to see some detail in this wisp. You know, that's really pretty. I know you prefer this one. You know, I get it. But what's interesting is that by looking at this other one, you actually get some of the better morphology imagery, so you can actually see what it's really doing in there. Like here, you can actually see really all the little fine detail in here that you just don't get to see in this one. It's sort of like covered up. So what you do is you take images like this one and you combine them with images like this one, and you end up getting a image that has the blend of both, which really is the best. It looks gorgeous. Thanks, James.
It is kind of reminiscent of the bubble.
Yeah, caused by the same type of star.
Yeah, maybe that's why I confused the two.
Maybe. That's all right. You were probably thinking Wolf-Rayet star all along, Daryl. You know?
Maybe. Maybe.
Maybe.
Revenant of the Swan.
Yeah. All right. Let's try looking at the Gamma Cygni Nebula since we're right here. In fact, I don't know that we even need to I don't think we even need to do anything other than just go there. Let's see here. Yeah, that's not the right way. Okay. I'm heading to the Gamma Cygni Nebula.
Uh-huh.
At least I thought I was. What's going on here? Okay, now we're going. Now we're going to a nearby bright star, which is going to be the Neb. No, not the Neb. Solder.
Solder.
Yeah, back to solder. And then from there, we're going to go see the Gamma Cygni Nebula. Not sure if it'll show up. And it might. Auto centering, and then just when you think it's gonna stop, boom, away it goes. Actually, this nebula is one that I photographed a few times around solder.
That's pretty big.
It is. I got some nice pictures of that. Let's let this figure out if it can stay here and see what it's gonna see. All right. And then I can tell it to go take a picture. 30 seconds at 25,600 ISO. The conversations are so exciting here. 30 seconds at 25,000. It's like, what? All right. And the idea is that we want to see if we can see the Gamma Cygni Nebula. Maybe, maybe not. But it's okay. We're on filter number 1. Yeah, filter number 1. Well, you can see a lot of red in here. That's definitely indicative of the nebula. So it's not going to be very well defined for us tonight. I mean, only because, you know, the way I'm taking the pictures. If I had a wide field refractor on this, that would be a very different story. I have to figure out how to get that on there because the guide telescope takes up all the rest of the room. You know?
Sounds like you need another telescope. Another mount.
Another mount, yeah. Another mount in a bigger building. I've decided that the number of piers out in the West Coast Observatory, there were going to be 2 diagonal piers. One was going to have the telescope we're using tonight, and then one was going to be a rental pier for a group, and we already have that, I think, rented. But I decided that I'm going to make a equilateral triangle of mounts in there, so there's going to be 3 piers, and the other pier is going to be for development of SkyTour West even further, so that we can end up doing a wide field telescope on a mount, and then do it'll be a wide field refractor actually on a mount, and then we're gonna have the regular telescope on the main mount, what we're doing like for tonight. That's gonna be really pretty. It's gonna work very well.
You might consider a Mach-Newt telescope for a wide field astrograph. Probably get one cheaper than you can a wide field refractor.
Yeah, no, I think astrograph might be the way to go for that other mount, but I have to wait and see where the monies come from. You know?
Yeah, well, they make Mach-Newt astrographs too.
Yeah, they do. And you're talking Maksutov Newtonian.
Right.
Yes. For people listening, they don't know what that is, so.
Sorry.
No, it's okay. Now they do. It's a type of telescope. Okay, this is nice, but not doing what we want. There's the North American Nebula. I don't want to go there because we're going to see more of the same. That looks really beautiful when we go with the appropriate. All right, I'll try it.
Try what? That looks like the ring right next to it.
Yes. And you're wondering why I'm not going right to the ring. Correct?
The thought crossed my mind.
All right. Of course, the problem is the dome is more directly in the way now, as you can see in the inset here.
Oh.
Literally half of the dome has been put over the telescope aperture. So maybe we're going to have to avoid that.
Music got loud again.
No, your ears started listening harder again.
Oh.
No. Yeah, it was I did turn it up a little bit by accident. Okay, the Andromeda Galaxy is actually pretty high up now. Would you like to see that?
Sure.
Okay, we're going to go there because this is not going to work with the Ring Nebula now. But let's try the Andromeda Galaxy. Oh, there goes the telescope. I wonder if I have to move it. Will I have to move the dome again? Oh, it's getting close. Maybe. Let's see where it goes. Let's see where it's aligning. What star are we aligning on? We're aligning on... Okay, well, look at that. We're aligning on Mirach. And then we're going to go up higher, which is going to take us more into the open space where we may not have the dome in the way. And it doesn't look like Mirach has got the... Doesn't look like Mirach has us in the way. Okay, well, there we go.
What filter do you have on now?
I'm going to look right now. I think it's 1. We're going to go to 2. Okay, we're moving filter wheel number 2. Alright, let's see where we are in the sky. Yeah, let's see here. We are apparently in the Andromeda Galaxy right here. Shall we look and see if that's true? 30 seconds at 25,600. Has to be true for you too. Here we go. It looks like the telescope may be in the clear, but hard to tell, you know, when you're looking at it like this. Hard to tell. Oh, good, Isabella. I'm glad you like the Andromeda Galaxy. Because it's about to show up. Here it comes. Oh, yeah, look at that. Okay, so this is just 30 seconds. And we're looking at the Andromeda Galaxy. Good guiding. You can see the dark lanes in here. We're actually looking at the middle of the galaxy. But if we were to take a picture of just a little longer, we would actually end up seeing more of the colors, and this beautiful mottled area would be more discernible. But I think we can do at 25,600, we should actually go to 1 minute looking at this with this filter. And then we'll go to 1 minute on the narrowband filter. This is the wider narrowband filter we're looking at now. Incidentally, tomorrow night, 10 p.m. Eastern Time, and 7 o'clock Arizona time, I will be doing a talk for the Phoenix MUFON folks. It's available worldwide. Everybody can watch. And you can come see. It's actually a talk that I've tailored just for people who like astronomy and want to know what's up in the sky. But it actually talks about a little bit more about the science of what's going on up there. And so it's basically an enthusiast's guide to the night sky. So I think you'll have some fun if you want to attend that. I believe it's free. Oh, look at that. Wow. That looks beautiful. Look at that.
Nice.
Wow. You can see these beautiful dark lanes in here. Yeah. That's something else. That's really pretty.
See an outer dark lane to the
Yes,
left
that's
of the really distinct one.
Right here.
Yep.
And right here. Then you see these little tendrils in here. Yep. Okay, now this is with the number 2 filter and not number 1. So if we go back to the 1 filter, holy cow, this is just something else. That's really pretty. Let's see if we can. Boy, I want to go higher, but I'm not gonna. I don't want to hold you guys up. Okay, and then 1. So now we'll do the same thing with filter number 1. By the way, the guiding system does not see what the filter sees. The guiding system's looking in white light. Okay, so it doesn't have any issues whatsoever with the filters. In other words, that could cause it to not see a star. Can you hang out for 1 second, Daryl?
Sure.
All right, I'll be right back, guys.
Oh, goodness. I hope you all have had fun tonight. It's been an interesting journey. Mark's got really clear skies tonight, looks like. He's been pushing the ISO all night. That's with the number 1 filter, I think. Changed the view very much. Actually, I suspect might get a better view of the galaxy either back with the number 2 filter or even with white light. The light from galaxies isn't in a particular wavelength so much like the narrower narrowband filter picks out. It's all wavelengths. A lot of yellow light and some blue light and red light.
Yeah,
that's your narrowband, Mark?
Yeah, we'd have to take that exposure a lot longer. Okay. I won't waste your time with that, folks. Alright, but I'm going to go back to number 2 and take us to a slightly different object that's nearby, actually.
M33.
No, say it isn't so. Yeah. I'm trying to remember which way M33 is from here.
Triangulum, right there to the lower right.
Yeah, that's right.
Or no, oh yeah, it is. Okay.
Okay. And then we gotta go here. What's interesting is when we look at the Triangulum Galaxy, you're gonna see something really cool, and that is we will be able to see some basically the Orion Nebulas and the Eta Carina Nebulas of the Triangulum Galaxy. So it's really, really interesting stuff. You'll see in a sec. So we're going back to Mirage again as our guidepost star, and then it's going to take us up to the Triangulum Galaxy, or should I say down to it. It's at 45 degrees above this horizon, so it's actually not going to be too bad. And it'll be right there in the middle, right where this shows it. So once it's aligned, away it goes. I don't know why I think this is going to look pretty nice tonight. I think it will. Okay, so now we're there. And I just have to make sure that the telescope knows that it's in its position. Okay. Make sure that we have like activate Windows. Make sure that we have a good view. Might have some dome interference, but maybe not. All right, let's give it a shot. Let's go 30 seconds. We'll do 30 seconds at 25,600.
Really been pushing the ISO tonight, haven't you?
Yeah, I've been pushing that sensitivity for the faint objects. Hey there, Celtic Warrior. How you doing? Oh, Gina, I'm so glad you like it. Thank you. Okay. Dome.
Dome.
Yeah, I'm gonna go move it, okay? Because this is really pretty.
Okay.
All right. I'll just drop you back to the Orion. I'm sorry, the Andromeda Galaxy for now. I'll be right back. Hang in there, guys. I shall return momentarily. As long as the bear or the mountain lion doesn't get me. Got both in the neighborhood now. Be right back.
Uh-oh. You'll like this one, folks. 33. Already. Hope to share it with you. Many years ago, 1980, I think it was again, I was living in that log cabin up in the mountains. I thought I actually saw M33 here with the naked eye. It's just the dimmest little smudge, but I had an absolutely coal black sky, and I was stargazing one night out in the front yard, and M31 Andromeda was obvious, and then I looked over to its lower right and saw a little smudge in the sky, and I think it was M33. That was naked eye. I miss the good old days. Don't we all, I guess? Living in the cabin was a neat experience. I don't know if I'd want to do that again, but we were in the woods at the very base of a mountain, and just off the top of a mountain pass, and it's probably at about 11,000 feet elevation. Beautiful dark skies, and that stream running behind my cabin, and coyotes out the wazoo. Coyotes would start singing late at night and freak my dog out. But it was a neat experience.
Hello, hello, hello.
Welcome back.
Hey, thanks. Glad to be back. Very nice. Okay. I'm really excited to take this picture now. Because it was dead center. I could see that in the red anyway.
Uh-huh.
Okay, 30 seconds at 25,600. We'll go to 1 minute at 25,600. Hey, what did you tell them that must have been thrilling that I missed?
Oh, I talked about living in a log cabin again back in 1980. I was at about 11,000 feet elevation, and just a dead dark sky, and I thought I actually saw M33 with the naked eye one night.
Wow.
I could have been fooling myself, but I thought I saw it.
Maybe not. This is beautiful.
Well, yeah, M31 was obvious, and I saw a little smudge of light, you know, a little faint fuzzy, and it was where M33 was supposed to be, so I think that's what I saw.
Wow. Well, here's a galaxy. You can see, and this is only a 30-second shot. It's got loose spiral arms. You see smudges in this galaxy. Smudgy things. And then we have one like this big. Okay. Now, I'm going to take a 1 minute shot, and it'll become clearer what we're looking at. But that, what you're seeing are actually nebulae over 2 million light years away in another galaxy.
I can see the one big bright.
Oh, Daryl just went away. If Daryl's gone, it's because his computer has rebooted on him, which happens from time to time with him. Oh, you're here.
I hit the mute button.
Oh, okay. You can see the big bright one down here.
Is that it? I was thinking the one that's up at about 10 or 11 o'clock in the center of the galaxy.
You mean this?
That one there? Yes.
Okay, I thought you... Well, you might be used to this. See, this is on an angle. You might be used to seeing it like this.
Okay. All right, that's it, yeah.
Okay. I rotated it, so it's a little bit more like it.
Very good.
Okay. And I'll do it again for this one. Okay. And
that's it.
And there you see it. That's amazing, isn't it? Yeah, this... So when we're looking at the galaxy, you can look at the spiral arms. There they are. You can't miss them, all right? And if we just do this, it's a little bit clearer, but you can see the spiral arms very nicely here. And this is called an SC, and I got a little walk here, so I'm going to just do this again. It's an SC spiral galaxy, meaning that the arms are not as tightly wound. And this object right here, this blue object, is really a dot, and that's actually, I believe, a planetary nebula that's out there in this galaxy. I think this one or this one. One of the two. There's another one over here. See, there's this one as well. Actually, this I think is in the galaxy. Very interesting, and even over 2 million light years away, the features are big enough to be seen. You can see, even though the shot it has poor guiding and we have it better, there's a nebula here, there's a nebula here, there's one here, here. There's literally, there have to be 40 or 50 or more that are known. This large association out here, this large grouping here, did we just take the shot? Is that what that was? Oh yeah, that's a better photo. Look at that. Okay. So when we look at this now, 1 minute shot, okay, you can see these objects out here better. Let me just show you these first. Okay. So you see this nebula has some blue in it. We got something over here that has some blue in it. That's actually in the nebula. I'm sorry, in the galaxy. And then you can actually see the spiral arms here. You can see individual stars almost down in this grouping here. And the arms are going this way, and like this way, and like this way, and like that way, and that way. And these are all nebulae that are in this galaxy. All these little clusters of nebulae. Right. This is a very, very large association of stars, a large OB association, O stars and B stars, all short-lived, all going to leave supernovae when they're done. And it's the equivalent of the Eta Carina Nebula here in our galaxy. If you look that up, Eta, ETA, Carina, C-A-R-I-N-A. So ETA, C-A-R-I-N-A, Eta Carina. Eta is a Greek letter, from alpha, beta, gamma, delta, epsilon, zeta, eta. Okay. And so that is about like the equivalent for the Eta Carina Nebula here. But look at this. All the knots in this object are just incredible. Yeah, really, really pretty.
It is.
We've taken photos of this where you can actually see all these hydrogen 2 regions in here, these star forming regions in this galaxy. Interesting thing, the nuclei of these galaxies typically is where the older stars reside, and it's the spiral arms where star formation takes place. And that's true in this galaxy as well. Same thing as in Andromeda. So now I want to actually take some time here, a moment, to see if we could identify some of these things. Some of these things are so big, okay, that they have their own names given to them, from here. So let's see. You can see they're identified.
Which have their own NGC numbers.
Yeah, they do. I'm trying to see where that large guy is. Interesting. Interesting. Okay, well, I guess we're not going to be able to identify it directly. The actual photo in the program is not that good. The photos we take are actually better than this program, actually, sometimes. Which is a good thing, right? It's not a bad thing. Look how clear that is. All good clarity, I'm telling you. Really nice. Yeah. Wow. Okay. Do one more. Wow. So this is what we took earlier. And I went to the right with it. Okay, I think I know what that is then. Is it NGC 508? No.
I think it would jump out at you in Stellarium.
Yeah, you would. I don't know. All right. No, you would think so, but maybe not. And this is really beautiful. This is a nice shot. See, we got one here, we got one there. We got one there, we got a big cloud there. Almost everywhere you look, there's a knot. Look at this. This is actual. You can't miss that one. So, yeah. Well, there you go. I mean, so we actually got a whole bunch of objects in tonight, which is really neat.
Yeah.
So, I hope you guys had a good time. I know I did.
I did too.
I'm just very pleased that the telescope finally started working properly again. I don't know why it didn't, and I'm going to have to figure that out. I tried to fix it by doing everything as if I was at a great distance. But that still didn't stop me from going out there and punching the dome as hard as I could at one point because I got so mad. Very frustrating.
Think of all the frequent flyer miles you're going to be racking up.
No, think of all the phone calls I'm going to make to people out there to go out and check the dome for me. I'm kidding. There's not going to be that much of that going on because this machine is going to work perfectly the entire time.
Knock on wood.
Yeah, exactly. So anyway,
I've said before, I think there would have to be a business opportunity, for telescope technicians to go, shall we say.
Oh, no.
Some places like Star Village out there,
yeah.
Similar places. I think a guy could probably pretty much make that a full-time job going out and maintaining the telescopes.
Yeah, why don't you do it, Daryl? I'd be happy to pay you to go out to fix the telescope when it goes haywire.
I'm retired.
Oh, okay. I get it now.
Wow. Mark, I'm going to call it a night.
Well, me too. Me too.
Flagging pretty badly here.
Yeah, no worries. I do appreciate everybody coming out. Thank you, Daryl, especially for coming out because
sure.
you make things happen here. But I do want to just thank everybody, and you guys are really good and kind, and I guess you're probably the best group that anyone could probably have. So I really appreciate your coming out. So we are done for tonight. We're going to say goodbye, and we'll catch you on the flip-flop. And tomorrow night, if you get a chance, listen to that's being publicized all over the place. And Tara, you said you're going to be listening to the talk or seeing it because it's a video talk. It's not just a radio. It's kind of a neat talk. I've done it before around the country, and people like it. I've got more than a dozen different talks I do, so they're changing all the time, actually. So I never really do the same one twice, so this will be a good one too. So if you're gonna be out there, you want to watch, it's gonna be via StreamYard, but I don't know where people go to find it. Tara, do you? If you're still here? Yeah, she is. Tara may know. She may answer. International UFO. Oh, thank you. International UFO Congress YouTube channel. There you go. Very good. Thanks, Tara. That was very, very kind of you. Terry Groff, man. You have a good night. Terry Groff, I've told you guys before, friend of mine in Dallas. We worked on a television show together. He was a amazing guy, let me tell you. And he knows the best sushi bars in Dallas. So, anyway, you guys, you have a good night. And I leave you with Messier 33 and Triangulum, the Triangulum Galaxy with all of its many nebulae and so forth. I will be back tomorrow. Daryl, thank you again, and I will let you go because I know you've been dying to get off the phone now for about 5 minutes. I apologize.
No worries. Thanks for having me on, Mark.
Of course.
Good night, everybody. It's been fun.
All right. Well, you guys have a good night, and we'll talk to you the next clear night, which could be as soon as the day after tomorrow, because I don't start until 10 p.m. Eastern time tomorrow on the radio. I'm sorry, on the video talk. All right, guys. We'll see you later, and have a good night.
Night.